Alrighty, so hello and welcome. Oh boy, man. Oh. I took a one of the Hackerrank exams, one of the certification exams, and I guess I did well enough to pass the exam, even though I failed one of the questions. And oh, dude, that was terrible. So frustrating. Oh, it's so funny. Um, yeah, basically, I got the certificate anyway. I took the test, but oh, it was terrible. I mean, it was okay. I'm grateful. I think I learned something at least. Yeah, it was a Java test, and there were a bunch of things there that I was not expecting at all. Um, but I'm glad I did it. I'm glad they asked questions that I wasn't expecting. I'd rather learn things rather than assume I know stuff. But one of the questions I thought was interesting was they had asked to use a parsing routine for one of the questions, and the thing that you were parsing was way bigger than what you would normally assume what they're looking to parse. Parsing integers, that is. There was an integer parsing subroutine, and I got the I got the certificate anyway, so I guess it's fine. But oh, brother, oh man, yeah. So one of the issues is the parsing routine. Yeah, it's. I'm sorry, I can't get over it. It's just so. I'm just grateful I actually got the certificate. It's like, okay, well that was the point, but like, I mean, I could have done that so fast, that whole thing, but dude, it's like, oh, I gotta be kidding me. Yeah, so here is the problem. Here's the issue. The part that you were debugging, like the part that I was trying to debug, the test cases, I couldn't figure out why I was getting the wrong answer, right? Because what happens is when you parse, if the integer is too big, your parsing routine is going to fail, right? And so I was failing on the larger integers that I was supposed to be parsing. And I did not think for the longest time to print the inputs that you're working with, so that way you can inspect how the program is operating on the hidden test cases. And it even said that in the instructions to do that, and it took me a while. It took me a really long time to think to do that. I didn't really think to do that. I was like, yeah, but because my thinking is like, if you have like a problem, like this is here, like this is what we want you to do, but it doesn't match what they actually want you to do, then you're just kind of stuck. Like, I can't actually fulfill that request because it's just not true. This is not actually what you're testing for. It's not actually what you're trying to do. So I guess it was an interesting question, because it was an interesting question because I noticed actually that the Java certificates, like there is C++ beginner, medium, and advanced certificates, and there's just one Java certificate. I think they must have had a lot of really frustrated people because very few people thought to actually debug the hidden test cases, which personally I think it is questionable. That it's really annoying, but it is something you do. When you're programming, is like trying to figure things out where it's not necessary. It's ambiguous. It's not necessarily like obvious what to do. My opinion is kind of poorly written. I think actually the truth is that it should really just be like what they ask. You shouldn't be forced to like debug because of the ambiguity of the question. You really should be forced to debug because of just like problems with sort of how things are. I'd say more arbitrary problems than that. Like that's an arbitrary problem, but like that's a problem of like communication. Like that's not really That's not an issue of like your own, maybe you have a logical error in your program and then you have an issue, right? Like that really should be why you're debugging, not really because you don't actually know what they're asking. That's like a really different. Yeah, I don't know, man. I question that. I know a while back someone had asked me about that, and I was like, yeah, well, I guess it's all right. It's like, well, I don't know. I don't know. I think you should try your best not to avoid that. It's okay if it happens from time to time, but you should try your best to avoid that. And I've noticed that in Hackerrank problems. It's quite a few times it's happened where the explanation of the problem is like kind of hard to understand. There's like some subtle thing that's like ambiguous that you can't really discern immediately. You have to actually check the test cases. But yeah, that was the issue, is that the numbers were a lot larger than you'd expect. And I was like, so what's crazy about that though is that I thought I had handled that, which is a little bit weird. I actually thought I had handled that with one of the routines that I wrote. So I don't know. There was something funky was going on. Something strange was going on with respect to that problem, and I couldn't figure it out. I didn't figure it out. Yeah, kind of wish I had a little bit more time to work on that problem, but what are you gonna do? You know what we're gonna do though? What we are gonna do though is we are going to go ahead and continue our studying of Ruby, or start our studying of Ruby. So yeah, we'll do that. I have like a lot of work to do too. I have to respond to, as a recruiter, I have to respond to. Yeah, so actually one of the things, let me see if I can find Roku. Interesting. Skills. Sync gaming. Find your dream job. Find your dream job. All right, well, let's do there is a practice. Problem solve algorithms. Yeah, hold on, let's see if we can find this one. What's the name of it? There was a problem, basic, or not even basic, just easy. And it could be solved already. We want, let's see if we can find this. I actually don't know how to search this. There's a way to search the site. Oh, there we go. That works. Let's do it that way. That's better. Let's do. There's a particular problem I want to work on. Challenges. Covariant return types. What is that? Oh, we already did this. Yeah. Okay. I think covariant return types in simple terms is just returning a subclass in an overriding method. Yeah, that's really what it means to have covariant return types. This technique called covariant return type means that the return type is allowed to vary in the same direction as the subclass. Yeah. Hidden, turning a value from a method, it's really hidden in there. Yeah, there's a little chart at the bottom here. That's not what I'm looking for though. Checker. Checkers? No. Type. Hackers. Index architecture types. OLAP operation type, basic data types. C++. Nope. I don't know. I guess that problem's not around. Alright, well anyway, I guess we won't be doing that. But let's just say there was a problem I wanted to look at. Let's just say there was a problem I wanted to look at. Okay, let's look at Ruby. Let's try that. Ruby tutorial. Hello, Hackerrank. Let's go. Let's do it. Let's get started with Ruby. Go ahead and type the following code in the code editor. Print hello, Hackerrank. Oh, didn't see that. Didn't see that. Print hello, Hackerrank. So this is Ruby. Here we go. Oh boy. Gonna learn things about Ruby. There's so much to learn too, by the way. Input, no cookies for you. Alright. Got 5 points. Next challenge. I think we gotta get a star first before we know how many questions there are in Ruby. Everything is an object. Print. Everything is an object in Ruby. For instance, if you type print self in the code editor, Ruby treats self as the objects in which it is currently referred to. Give it a try. Self. So it's like Java. Everything's an object in Java. Main. Okay. Everything's a class in Java. Okay. 20 points for that. Wow. Or no, excuse me. 10 points for that. Great. I guess you gotta get the first star then, and then it'll tell you how many questions there are. Each object in Ruby may have methods associated with it. To demonstrate this, we want you to print whether a number is even or odd. A number is an even question method associated with it, which returns true or false based on the parity of the number. Oh yeah, there's Ruby docs too. The Ruby docs are kind of interesting. I like the Ruby docs. I think this is. There are a few different websites. Like I don't know what's the official Ruby doc language. I guess it's this one. I don't really know. There's a few. I've seen a few. Yeah. It's the official Ruby docs. I don't know. Ruby Lang. This is the one. There's Ruby doc and there's Ruby Lang. Right. I've used both. I've used both. I don't know which one's better, but they're both useful. Anyway, so what are we doing? I want you to print whether a number is even or odd. A number has an even method associated with it, which returns true or false based on the parity of the number. Assuming a variable number is already defined, check whether a given number is even or not. Type in the code editor, return number.even or number.even. First line of input contains integer n. The next n contains one integer in each line. The output is handled by the code written in the editor. So, wow, it's so terse. I remember that in Ruby, it's super succinct, super terse. So they were saying, do you not need a return? You don't. Oh, that's interesting. Ruby, you can just you just call it. It just doesn't even. Wow. Okay. Whoa. Whoa. A method may take 0 or more parameters as input. To demonstrate this, we look at the assets asserts we use on Hackerrank. Sometimes we have to check whether a given number A is within the range B and C, where B is less than or equal to C, both inclusive. 3 variables A, B, and C are already defined. Your task is to write code that checks whether A is within the range of B and C by calling the method range, which we have defined for you as a method for this example, on A and passing B and C as arguments. So a method may take 0 or more parameters as input. To demonstrate this, we look at the asserts we use on Hackerrank. Sometimes we have to check whether a given number A is within the range B and C, where B is less than or equal to C and both inclusive. 3 variables A, B, and C are already defined. Your task is to write code that checks whether A is within the range of B and C by calling the method range, which we have defined for you as a method for this example on A and passing B and C's arguments. So A.range BC or. Oh wow. Oh yeah, right. There's multiple ways to write Ruby code. Excuse me. So you don't need to return, and then also you can write. You can use a excuse me. You can use parentheses for the function call or not, which is sort of what you're seeing here. So they're saying range A.range BC, and that's Ruby code. Ruby that'll compile. That's Ruby code and work. Constant fixed num is deprecated. Not a clue what that means. Okay. Introduction challenges. Alrighty. First star. Here we go. The adventure begins. So it doesn't actually tell us how many problems there are to solve. It just tells us how far we are from the star. Okay. I guess I have to get all the stars and then there's more problems to do. Variable arguments. Okay, in our previous challenges we explored some ways to pass arguments to our methods. However, they were limited in terms of the number of arguments we could pass to them. Using default parameters allows us to lower the number of arguments in some cases, but it's not helpful in situations where we need to pass a variable and potentially very large number of arguments. Consider a method that computes the sum of numbers. Obviously, you wouldn't want to write different methods accounting for some variable number of arguments, summing 2 numbers, 3 numbers, 4 numbers, etc. So Ruby's star comes into play. Take a look at the following code. So this is pretty interesting. You can do this. This asterisk operator is also present in Java, which is kind of neat. It's also present in Ruby. So sum first star. Oh no, excuse me. It's present in Python. Sorry, not Java. I take that back. Not Java. Python. Yeah. So sum first asterisk rest. Rest.reduce first O plus x. Okay, interesting. So this is probably the initial. Dude, I remember Ruby. I programmed Ruby like so long ago. This is bringing back memories. I used to play online with other people, and we would play like a programming game where you would be given a task and you'd have to write, like, the first problem to solve the task would win the round. And I would always use Ruby because Ruby was so terse that if you could program it in Ruby, it would be very quick, and it would be you'd be able to beat other players. Where was I thinking? Yeah, you'd be able to beat other players. And I'm sorry, I'm just thinking back to those days so long ago. That was like 6 years ago, 7 years ago now. Oh man. Those days were different. But wow. Yeah. Wow. But anyway, I would use Ruby because it was fast. Because Ruby, it's very terse, so it's fewer characters, less typing. It makes it faster, and then also it was, there were challenges that were like quote-unquote code golf challenges, where you would try to use as few characters as possible, and again, Ruby was really fast. So this is kind of bringing back some memories of when I kind of first learned about Ruby. But I remember that you can sort of write, these are basically like lambda functions, just written inline functions, just right there. Which in C++, lambda functions, inline functions are kind of unusual, but in even in Java too, it's a little bit unusual too. I mean, they have lambda expression support, but in something like Ruby and Python, Ruby is like, there's lambda functions all over the place, inline functions all over the place. But yeah, JavaScript and Ruby and Python, there's a little bit more of that, those inline functions. All right, so this is where Ruby's asterisk comes into play. Take a look at the following code. Sum, first, rest, reduce. So this is the initial value, and then it's going to do a reduction where it's going to call this function over and over again. This function is written in such a way where these are the parameters to the function, and then this is the actual function itself. So sort of the return value as well. So that's pretty interesting. And this is I think they call this a splat operator. Yeah, there we go, splat operator, right. So in Python, it's actually not the splat operator. So that's why I kept calling it splat operator. In Python, it's not the splat operator. This is the splat parameter this is a splat parameter for the function signature. We call it a splat parameter, but in Python, it's actually an asterisk operator where it's the other way around. You would give the argument, you would apply an asterisk operator, and what it would do is it would actually sort of unpack all the data structure, I guess, or the list into unpack the list into arguments for the function call, rather than sort of the other way around, where where this actually causes the inputs to become variadic. So this is more like a variadic, sort of like in Java, if you have ... that's more of like what this operator would be. But in Python, it's used slightly differently. So that's why I have to be kind of careful when I say splat operator. In Ruby, it's a splat operator. In Python, it's an asterisk operator. And they work differently in the languages. So it's subtle, but yeah, I remember that too. I was kind of confused by that when I was younger, but yeah, interesting. So Ruby has that operator. Gotcha. To cause a function to become variadic. It's like, brother, we're going like right out the gate with Ruby. Ruby's a whole different animal. It's right out the gate, variadic arguments. That's pretty wild. Yeah, that's Ruby though. It's a whole different beast. Okay, prepending an asterisk or splat to a parameter assigns all of the values starting from that position in the method call to an array named rest inside the method. In this case, our method has at least one required parameter named first, and then any subsequent values are assigned as an array to rest. Write a method named full name that generates the full names of people given their first name, followed by some variable number of middle names, followed by their last name. So Harsha Bogle, Pradeep, Suresh, Satyanarayana. Pradeep, Suresh, Satyanarayana. That's quite a name. It's an Indian name I'm not familiar with. Full name, Hork G.M. Moon. Okay. All right, I think I got it. So we're going to write a routine, call it full name, define full name, and we're going to say similarly, as suggested, we have, so first name, last name. So first, last, and then we'll have a splat, middle names. And you notice in Ruby, you do use snake case. So there's snake case for Ruby and Python, and I guess not JavaScript. Ruby and Python, and then all the other languages use camel case. So it's fun. So we're gonna do the same thing. We're gonna do middle names. Well, you can do something like this, like first plus middle names dot reduce. And Ruby syntax is like super concise. Which actually you can do, first name could be the first element. And then same, you do literally the same exact syntax. You have AB, and you have A plus B. And that's it. That's your whole function. And then that, once you finish that, you can concatenate that with last. I don't know if it's plus last. I guess it'd be plus last. Yeah, something like that. Ruby is super terse. Whoops, are you sure everything's all right? Successfully completed this challenge. Look at this. Uh-oh. Huh. What if we did, I don't know if this, I don't know. So the thing with variadic, I think Ruby's one of these. Yeah, I think the thing with variadic other names, something like that. The thing with variadic arguments is that I think you can only have it at the end. Oh. We're just gonna, yeah. Yeah, I think you can only, oh, there's no last element either. What was I saying? So you can only have, what is going on? Excuse me, full underscore name. Def and reduce. What is, what's wrong? I'm very confused. Also, Ruby, I know, yeah, Ruby and Python use the same syntax for multi-line comments as well. What is, what's the issue exactly? Whoops, are you sure everything is all right? I'm a little confused. What's going on? What's the issue? This should actually give you the right answer. Hackerrank can be really annoying sometimes. We're gonna print, so puts is actually what I would use instead of print, and you can put everything, I think. Fizz, Buzz, Senorita, Senora, S.A. Vishnu, some big random name. Whoops, are you sure everything was alright? This test case. This is so funny. Expected output. You've successfully completed the challenge. How is it that we're not needed? This is so funny. What is going on? What is happening here? Dude. What am I looking at? What is going on? Ruby's such a fun language. What? Oh, where's the part that's wrong? Excuse me. That's what I'm confused about. Oh, that's so funny. Yeah, what's interesting is, oh, my head. My head, man. That's so funny. Some big random name. All right. So there are a few, right? There's Fizzbuzz. There's Senorita, Senora, S.A. There's Vishnu. Some big random name. Oh, you're supposed to have a space between them. That's what they're looking for. That's my mistake. Okay. Oh, I totally missed that. Whoops, I don't know why. What did I do? What did I do? Also, I don't know if this works, this other one. I don't think this is what they wanted. I think they wanted just the first name and then other names. Yeah. Okay. I mean, we just basically assume all the other names are their, so really this is like just a copy of the others. First, rest, and then it's pretty much the carbon copy of what we just saw. One character in between though. That's so funny. All right. Yeah, it looks like it's not. So what I was saying about the variadic. So okay, so this is kind of what I want to check though. Can we do this? It's not going to work in some cases. Oh, that's interesting. Whoa. Really? No kidding. Huh. Oh. I don't know. I don't know why that works. That's kind of weird to me. Hmm. Because there was one that okay. Fizzbuzz, Senorita Senora Say, some big random name. First last. Oh, they do all. Oh, okay, that's interesting. This is what I wanted to do originally. I was just missing the spaces, I think. So there was a Vishnu somewhere in here, so I guess we just didn't call Vishnu on, right? Like that was kind of what I was trying to check, was that there must be, if there must be a last name, then somehow that works. I don't know. It's weird. Either one of those worked. I mean, I think that it would, but I guess what I'm trying to ascertain is like whether or not this, you can actually do it this way, where you can have like two different parameters and then a variable number of parameters in between. I don't know. It looks like you can, but it's, yeah, it's kind of strange to me. But okay, just curious. Previous challenge, we explored one way to pass a variable number of arguments to our methods. While it may seem handy feature to have, except few circumstances, you are never going to use that many variables for your method. Also, okay, okay. So why do we do that? Oh man. I like Ruby a lot. Ruby's great. Ruby's a fun time. It's like you're never gonna use this, but but we did it anyway. Okay, sure. Oh, it's so funny. Excuse me. Oh boy. Okay. In our previous challenge, we explored one way. I'm sorry. Ruby's like an extremely popular web development language too. Like Ruby on Rails is like ridiculously popular, so it's just really funny to me. It's like, I don't know, dude. Ruby's great. Ruby's a good time. All right, let's try to gotta focus here. You're never going to use that many variables for your method. Also, if you are passing several different types of variables to the method, which then will be assigned to the array, it can be difficult for the programmer invoking the method. Excuse me. To remember the proper order for those arguments. Ruby allows you to partially mitigate this problem by passing a hash as an argument, or one of the arguments. For example, you have a method that takes a URI to download a file and another argument containing a hash of other named options, proxy timeout, active connections, etc. So fetch file URI options of options.hasKey proxy do something. Main problem with this technique, however, is that you cannot easily set default values for arguments. Read more. Interesting. Since this construct is highly useful, Ruby 2 introduced keyword arguments which allows you to write foo, x string foo num, x string num foo 13, foo 13 string bar. Interesting. Oh, I see. These are defaults, basically named. I don't really know. Oh, I see. Okay. So you can pass a hash, or you can incorporate that directly into the. Yeah, that makes sense. Okay, they didn't really spend very much time explaining what the value of this is or what this is, but yeah, that's I understand. So basically, you can use a hash map of the parameters. So you've named quote unquote named parameters. Python does a similar thing. Also introducing the double split. Yeah, I think actually this operator is available. I'm sorry, I actually think this is the variadic operator works both for Python and Ruby. By the way, I actually forgot that Python and Ruby do have both of these for the hash maps and for the variadic named parameters and also variadic unnamed parameters. Yeah. So let me do its counterpart, collects all the extra name keywords as a hash parameter. Yes. In this challenge, your task is to write a method convert temp that helps in temperature conversion. The method will receive a number as an input, temperature, a named parameter, input scale, scale for input temperature, and an optional parameter, output scale, output temperature scale defaults to Celsius, and return the converted temperature. It should perform interconversion between Celsius, Fahrenheit, and Kelvin scale. Ah, yes. Temperature conversion, one of the classic things to do with the computer. Is this why you went to school for 6 years, so you can learn how to convert temperatures automatically? is that why you did that? Forgive me. Forgive me. Input values are lowercase version of corresponding scales. Okay. Input scale, output scale, convert temp. So what do you want to do? Excuse me. A number as an input and a named parameter input scale, scale for input temperature, and an optional parameter output scale. Defaults to Celsius. So how do we make it optional? Well, I guess all the extra ones would be optional, but I don't know if there's a way to write it as optional. Sure. So temperature is going to be value input scale defaults to oh, I'm so confused. A number, a named parameter, input scale. How do we make sure it's not optional though? It looks like both of these are optional. I'm a little confused here. I don't know. I don't know how to do that. Oh. Well, that's interesting. I don't know. What do we say? If input scale equals, is it like equals, right? Dot equals. Did they do it? Dot .hascii options dot .hascii. I guess there's dot equals Fahrenheit. Or oh, okay, there's a few, right? The if statements just end, yeah. So I guess depending on the pairs that you pick, there are different options, but you can convert everything to Fahrenheit and then convert everything to everything the rest and do it that way. Do nothing. Let's do, is there else if? I think else if is what you didn't do in Ruby, yeah. Celsius. So first things first. Don't do anything. Scales are equal. Yeah, we want to return here. So Fahrenheit, we don't do anything. If we say, so we don't need that. If it's equal to Celsius, or really if it's not equal to, oh yeah, actually, yeah, it's Celsius. So we want to say val, so we're going to convert to Celsius. If it is Celsius, the input scale, or no, if the input scale is Celsius, we're going to convert to Fahrenheit. Celsius to Fahrenheit, and Fahrenheit to Celsius is, it's like 9/2 or something, I forget what the, it's actually, it's 0 to 32 and 100 to like 212, something like that. Boiling point Fahrenheit. So you actually don't need to look it up. Do need to know what the boiling point is though. I think it's 212. Oh, okay. Oh my. Whoa. 212, yeah, okay. So just real quick, Fahrenheit scale 0 is 32 to 212, while Celsius 0 to 100. So what that means is subtract 32 from Fahrenheit, and then you want to make that multiply by a factor to give you 100. So you have sort of x times, call it alpha times y equals 100. So y is going to be 100 over alpha, which is 100 divided by 180. Turns out, right? 212 minus 32 is 180, which is 5/9. So subtract 32 and multiply by 5/9. So convert to Celsius or convert to Fahrenheit. Right? Out of 5/9, and we can make these doubles. And then if it's Fahrenheit already, then we're fine. We're going to use lowercase, right? Celsius and Fahrenheit. Yeah. Kelvin is interesting. Looks like we only have Celsius, Fahrenheit, and Kelvin. Fahrenheit, we leave it as it is. Celsius, so we're going to convert to Fahrenheit, and then if they're not already equal to each other, the input and output scales, we're going to convert our input scale to Fahrenheit, and then convert whatever the output scale is. We're going to convert this to that output scale. So we're going to have an intermediary in between, so we don't have to deal with all the different possible situations, scenarios. So we're going to kind of crimp everything into one just go from everything to Fahrenheit and then from Fahrenheit to everything else. That way we don't need to figure out, all the different relationships between them and handle those. So having that one a common intermediary step, kind of like an abstraction layer, which is kind of neat. But yeah, anyway. So input scale, that equals Kelvin. So the deal with Kelvin and Fahrenheit, I think it's Fahrenheit, or is it Celsius? There's a relationship between Kelvin and Celsius. Basically, it's either Celsius or Fahrenheit. I'm actually not sure which one of these we want to use as the intermediary, but one of these I think you just subtract a constant for Kelvin. So it's basically Kelvin is supposed to have like absolute zero temperature, which is kind of neat. So we look at that. I think it's related to Celsius, not Lord Kelvin, the namesake of the unit. Base unit of temperature in the International System of Units, having the unit symbol K, is named after the Belfast-born Glasgow University engineer and physicist William Thomson. First Baron Kelvin, by fixing the numerical value of the Boltzmann constant to this very small number. 1 Kelvin is equal to a change in the thermodynamic temperature that results in the change of thermal energy by this amount. Kelvin scale fulfills Thomson's requirements as an absolute thermodynamic temperature scale. Uses absolute zero as its null point, low entropy. The relation between Kelvin and Celsius scale is this. So it's Celsius plus an amount. So actually we want to convert to Celsius rather than convert to Fahrenheit, because it's easier to convert from Celsius to Kelvin. Pure water freezes, it boils 273.5 Kelvin. Oh, I see. So that's why you add, that's how you figure out the relationship between Kelvin and Celsius. But what's interesting is that they're considered to be the same unit, that they have the same factor. That's the interesting part. So actually we want to say it's Fahrenheit. Fahrenheit. Convert to Celsius. So actually you go the other way around. So you're going to reverse this. You're going to multiply by 9 over 5, and then you're going to add 32. And then Kelvin, if the input scale is Kelvin, also convert to Celsius. We're going to say this is val minus 273.15. Okay. And then now convert Celsius to the output scale. So if output scale that equals Celsius, turn val, else if output scale dot equals Fahrenheit, return, so convert back. Again, we covered this case. Convert to Fahrenheit. So we were saying you subtract 32 first, and then multiply by 5 over 9. And then else if scale dot equals Kelvin, convert to Kelvin. It's weird that I'm using proper English here, like capital letters, capitalization here, but not on the parameters. That's kind of weird. Maybe I shouldn't do that. Maybe that's wrong. I think it's wrong, yeah. That's confusing, I think. The string representations don't need to have to be capitalized, but I think when you're referring to it in common English, it should be capitalized. So here you would add 273.15. Okay. And then return value. And you don't have to return at the end, it'll just return automatically. Compilation, end of input, expecting end. Oh, yeah, thank you. Even though Ruby is a scripting language and it's interpreted, you still you have these constructs. Convert temp, undefined, method equals. Oh, equal, okay. My neck, man, my neck. Something went wrong. Please check your answers. Interesting. Puts, val, puts, input, scale, puts, output, scale. All right, what do we get? What do we get? 0 Kelvin Celsius, 393 Kelvin Celsius, 400 Fahrenheit Celsius, 333 Fahrenheit Kelvin. Something went wrong. Really? But what are we expecting here? Celsius to Kelvin, add that amount. Celsius to Fahrenheit, 0, 32. So if the input is Fahrenheit, we're going to convert to Celsius. Oh, had it right the first time, actually. This is the other way around. This is convert to Celsius is this one, convert to Fahrenheit is this one. I got that confused. So, yeah. So Fahrenheit to Celsius is this one, and then Celsius to Fahrenheit is this one. Okay. I think that's what I got wrong. Still wrong though. Celsius to so if it's Fahrenheit, then we convert to 5/9 of, right, so 212 minus 32 would give you 180. 180 divided by 9 is 20 times 5 is 100. Right, so you get 100 for Celsius, and then you convert that. If you convert that to Celsius, you just return. If you convert that to Fahrenheit, what's the default return? Default's to Celsius, yeah, that's fine. Right. To just return that Celsius. If you're converting to Fahrenheit for whatever reason, so whatever if the input is like Celsius and then converting to Fahrenheit, then you would multiply by 9/5, so you get 180 and add 332. That's fine. And then Kelvin, Celsius to Kelvins is add, but from Kelvin you subtract. And this is not correct. What are they expecting though? What are the right answers then? So Kelvin to Celsius. So let's actually put Really, this should just do nothing, I think. Oh, that's why. Oh, that's okay. I see the problem. Yeah, that's the issue. Okay, I see the issue. Okay. I think, I don't know, maybe it's not the issue. Maybe I'm wrong, I don't know. Maybe I'm crazy here. I don't know, man. Something's not right. This takes so much time, these questions. It's really annoying. So 0 Kelvin Celsius. No, that's wrong. That's wrong. Zero is in Kelvin, and we're returning Celsius. 0 Kelvin Celsius. So Kelvin we convert to Celsius. So intermediary is 0. Okay. So that's not correct. That's a little bit strange. A little bit strange. Does this not, does this not do what I think it does? Yeah, it's very peculiar. How do you change variables in Ruby? Ruby arithmetic. How does that work? We use Stack Overflow here. Does this give it a new value to val? That's the thing I'm so confused about. Oh. Wait, what? Put that in the wrong place. I'm so confused. Something's going on here. It's confusing. Oh, so... Is this why? Oh, no. Learning about Ruby here. So this first Kelvin is not being called at all, even though it's equal to this string. So maybe that's what's wrong. Input equal. So let's do Ruby docs for equal. Look at all these ads. Also doxing my location too. Syntax. We're looking for. By the way, a lot of these are the same in Python too. These characters. We're looking for. Give me expression, keyword argument. Hash and keyword arguments must be contiguous. Default positional arguments. My method. I'm looking for keyword arguments. That's interesting. I guess they always have a default value then. I'm looking for I'm kind of confused here, but anyway. So what we're looking for is what about, actually, did they explain name parameters here? It's like a few things we're looking for at the same time. I don't know. I'm not sure what is meant by named parameter. I think it's really just should be like that. Because you have to have a default, I think, for your these other parameters. Excuse me. Oh, that's interesting. Input scale, output scale. Oh. I don't know. It's weird. For some reason that comes out correctly if we do it this way. Anyway, oh, the equals that we're looking for, right? Yes. So looking for string. It's not really string IO. We're more looking for just not URB. Class string. There we go. Seems like better docs than the other one. ISSJIS. Other self-encoding is shift.js. Is shift.js. Interesting. Path map explode. Okay. Complex. All right. Big decimal. Interesting. Scanf. We're looking for. It's got so many functions, methods. We're looking for equal. Oh, okay. Comparison. object is not a string, return false, otherwise return true if this returns 0. Okay, so you can do equals, but isn't there like a dot equal question mark? Two strings are go to the same length and content. EQL. So does this function not exist? That's my question. I don't know if this method exists. False. Oh. EQL? True. So I think equal is like object equality. And I think that, I don't know what that does. So yeah, this documentation seems to be a lot better. So that's what the problem seems to be, but at the object level, returns true if only if object and other are the same object. Typically, this method is overridden in descendant classes, provides class-specific meaning. Unlike equal equal, the equal method should never be overridden by subclasses as it is used to determine object identity. That is A equal B if and only if A is the same object as B. The EQL method returns true if object and other refer to the same hash key. This is used by hash to test members for equality for object of class. Object EQL is synonymous with equals equals. Subclasses normally continue this tradition by aliasing EQL to their overridden equal equal method. But there are exceptions. Numeric types, for example, perform type conversion across equal equal but not EQL. So what's interesting about Ruby is a lot like Java and JavaScript, I guess, in that it's like objects. Well, everything's an object. Like it's very similar to Java. It's like a really kind of like a wild version of Java. I guess the way I think about it. So here we are, we're exploring. So we do EQL, we also just do equal equal. I think EQL is better because it kind of keeps you in line with Java, like how Java operates. And it's interesting that actually C++ is totally different. I think C++ is just I want to say equal equals. Also now it's working a little bit better. What does Java C++ do? C++, when you have two objects testing equality, I actually don't know. I mean, I know it, but I can't remember it now. Object equality, I think, is like totally custom in C++. Yeah, you basically would define a function to determine whether or not the two objects are equal to each other. So strings have an operator overload for comparisons. Usually it's lexical comparison. Yeah, actually comparing objects in general is actually like custom. You can override the equals equals operator to do that. Thinking how is it done? Yeah, I want to say it's just basically just custom. It's like totally custom. So like you don't really have you have kind of the same notion, I guess, that Ruby has, maybe something like that, where you would actually override the operator, the equals operator, and then there just isn't, because everything's not an object. You don't have that notion of like a top level object and checking if objects are the same object. You don't even have that. Excuse me. I guess what you would do is really you would just take a reference and check if the two references are pointing to the same location. You take the address and compare. What was the answer? Compare. For overloaded comparison operators. Yeah, that's basically, yeah. Smarter implementations. Yeah. Pretty neat. We're not going to accept any cookies. No cookies. No cookies. Neat. So that's what we did wrong. We need .eql or equals. It's overridden. Okay. Yeah, C++ is, it's like totally custom, the object. Okay, that's pretty nifty. Learned a little more about Ruby here. Higher order functions are one of the key components of functional programming. Fair enough. A higher order function is the tool that takes other functions as parameters and returns them as a result. I like how many points you get for deleted. Oof. Rest in peace, that guy. Okay, blocks are nameless methods that can be passed to another method as a parameter. Blocks are nameless methods that can be passed to another method as a parameter. Higher order functions are one of the key components of functional programming. A higher order function is a tool that takes other functions as parameters and returns them as a result. Yeah, oh, I forgot about that. Yeah, so it's been a while since I've looked at functional programming. It's been like a couple of years now, but I learned a little bit about functional programming, and it's very neat. Yeah. Right. Monads and higher order functions and all these different concepts that I forgot now. Passing a block to a method is a great way of data abstraction. Blocks are nameless methods that can be passed to another method as a parameter. Yeah, so, okay, that's what a block is. Got it. Blocks can either be defined with a keyword do, ... end, or curly braces, ... Neat. Passing a block to a method that takes no parameter. Call block, start of a method, yield, puts, end a method. Call block do, puts, I'm inside callback method. Start a method, I'm inside callback method, end a method. In this example, a block is passed to the call block method. Oh, interesting. To invoke this block inside the method, we use the keyword yield. Calling yield will execute the code within the block that's provided to the method. Oh man, I forgot. Yeah, this is something in Ruby. This is such a weird thing in Ruby you could do. Ruby is not a functional programming language, but it has blocks, which are super interesting. Yeah, Ruby, dude, like I said, Ruby's so wild. Ruby's so bizarre as a language. I mean, it's great, but it's got so much going on. Ruby's also probably one of the slowest languages too. Like Python and Ruby are both extremely slow. Python, Ruby, and JavaScript, all the scripting languages, the interpreted languages are very slow. Calling yield will execute the code within the block that's provided to the method. Oh, that's interesting. Okay, calculate AB, yield AB, calculate 1510 with a block. 5. Oh man. In this example, we've defined a method to calculate that takes two parameters A and B. Yield statement invokes the block with parameters A, B, and executes it. Do this. That's great. Partially complete code. Your task is to fill in the blanks. The factorial method competes n times n times 1 times n times minus n times n minus 1 times n minus 2, etc. Oh, excuse me. Excuse me. Also gets to I remember using that quite a bit in my I remember this in my it was code golfing years ago. Okay, so gets to I, factorial do, And we're going to call factorial with this block. We're going to put, so this is just simple yield. And this is puts. We can use a reduce. You ready for this? You can do range, I think. How's it go? It's like, it's, ready for this? It's 1 dot 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 n dot reduce with 1 a a b a times b, something like this. This is quite the puts quite the thing, or a two-string. Yeah, something like this. I think that works. You can try that. Oh, it's wrong. Okay, string. Oh, it doesn't have a string. There's another way of doing this. It's like, you can actually do string. I think that works. Something like that. I don't know. Or two string. 2s. That's the one. Yeah, that's what you need. Yeah, look at that. Oh, that's phenomenal. Oh, that's so funny. Oh, that's great. Oh, it's so good. Excuse me. Yeah, that's good. I like that. Oh, man. I don't know what this should look like, but that's one way of doing it. Dude, Ruby. Ruby's so good. Ruby is so good. You gotta love that. You gotta love that. Second star. All right, we're moving on up, moving on our way. Yeah, see, I remember this. I remember these different syntactic things you can do in Ruby. That's so much fun. That's so much fun. Grateful we get to program in Ruby again. Passing blocks is one way to pass functions as arguments to other functions. Blocks are one of the very few exceptions to the everything is an object rule in Ruby. Blocks are not objects. They can't be saved to variables. Oh no. Proc block objects are blocks of code that can be bound to a set of local variables. You can think of a proc object as a saved block. Procs are a great way of keeping your code dry. Dry stands for do not repeat yourself. Keeping it dry. Repetition of software patterns, replacing it with abstractions, or using data normalization to avoid redundancy. Dry principle is stated as every piece of knowledge must have a single, unambiguous, authoritative representation within a system. The principle has been formulated by Andy Hunt and Dave Thomas in their book, The Pragmatic Programmer. They apply it quite broadly to include database schemas, test plans, and the build system, even documentation. When the dry principle is applied successfully, modification of any single element of a system does not require a change in other logically unrelated elements. Additionally, elements that are logically related all change predictably and uniformly and are thus kept in sync. Besides using methods and subroutines in their code, Thomas and Hunt rely on code generators, automatic build systems, and scripting languages to observe the dry principles across layers. Oh, that's interesting. 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 Not really sure. Fully understand. That seems very abstract. We'll leave that for now. All right. So my proc.call ab add equals proc. So you can save basically save a block in a proc. Interesting. Foo 1510 add calls my proc. So that is confusing, but I think I get it. Proc add, which adds two numbers. The proc add is passed as a parameter to the method foo. In the method foo, my proc.call ab executes the proc. You're given a partially complete code. Your task is to fill in the blanks. The square of sum method computes the sum of the elements in an array, input array, and returns the square of the summed elements. Excuse me. Square of sum computes the sum of the elements in the input array in an input array and returns the square of the summed elements. Okay. So proc square number, proc sum array. So this could be proc square number. It's going to be a turn a times a, and then proc sum array. We can use reduce or sum. I think sum actually works. I think there is just a sum in accumulate Ruby docs. Let's find out. Sum. There was a really interesting check this out. There was a really interesting, you ready for this? There was a really interesting it was something like this. There was a really interesting I think it's something like this. There was a really interesting way of specifying a summation in Ruby that was very terse. I think it was something like this. I actually don't remember exactly how to do it, but I think it was like this. So it was a while ago. Brain spec. Interesting. Foo, and you can use a block. And so that gets to be part of one of the options. I don't really know what that means or how that works. They're also, yeah, I remember these too. These are kind of interesting. These are another thing in Ruby. They're like item names or something. I don't even know what you call them, but they're special. They're like their own entities that represent like keys, kind of a thing. And they're not really any particular, they're not strings or ints or anything. They're just kind of like their own entities. That's another peculiar thing in Ruby. Ruby's got it's got a lot going on. It's like very interesting. Oh yeah, this is it. Yeah, this is one of the operators. I think this is actually exactly what you would do. You do this operator creates like a block operator, parenthesize the method arguments if it's surely a block operator, add white space. Yeah. Anyway, I think it's plus. You do something like this. I don't know. It's weird. It's so weird. I don't know. I don't know what's gonna happen here, but anyway, so we have myArray.gets equals gets.split.map Right, it's this this block operator. That's so interesting. 2i. So we map 2i. So this, yeah, I remember using something like this years ago, so long ago, to get to quickly parse input. Like if it, yeah, yeah. Oh man, this is so cool. So interesting to see this. So my array gets your input, and right, it'll get, I think, get string, really, I think it's string, splits the string, maps all these integers to integers, and then place that in your array. And then here we're going to say put square of sum with my array with these two procs, square number, proc sum array. And so we proc square. Sum is going to be proc sum.call my array, and then square. Well, this is the sum square, not the square of the sum of the squares. Oh, I see. Okay. So this is fine as a block, and then this is a block that uses another block as the reduce, so that way we can map. Well, not map. It's a summation of these integers. I don't know if this one will work. Let's see what happens if we do this. Could do some interesting things in Ruby. Basically, we would want another block here, which is AB, and then just A plus B, right? More or less. Yeah. So that works, but then you can do, how about this? How about that operator? What happens if we do that? Oh yeah, it does work. Yeah, look at that. That's so cool. I don't know why, but for some reason you can do that. It's just so weird. It's the weirdest thing. Excuse me. Yeah, that's great. That's a lot of fun. That's a lot of fun. I remember that. I remember that. I don't even know why that works, but it does. I don't know why that works, but it does. I'm pretty sure you can remove these characters too, and it'll work also. Oh no, it doesn't. Okay. Maybe you need this. Yeah, it works. Yeah. Well, that's not really. This is what they had, but yeah, I think you can do the same thing here. Yeah. But you can leave that out. That's fun. But I remember that too. That's how I would do summations in. That's how I would do sums in. Like that was my accumulation function in my code golfing, and when I would quickly write a sum. Yeah, super concise. Neat. I'm having a good time, man. It's memories from way back when. I mean, we're talking like years ago. Yeah, I was younger then, and had a lot more. I don't know what you would call it. Like I guess I had a lot more hope back then, which is kind of a sad thing to say. But I was a lot younger, and it was just like you had the whole world ahead of you. You could do all kinds of things that you could do with your time and your life, but a lot of things did not really come to fruition in my life. I guess something like that. I don't know. I don't know what to say. Anyway, lambdas are anonymous functions. So blocks are not lambdas, not anonymous functions, and neither are procs. But lambdas are a bit different. So lambdas in Ruby are objects of the class proc. Okay, so lambdas are a kind of proc. Got it. Useful in most of the situations where you would use a proc. Simplest lambda takes no arguments, returns nothing as shown below. So lambda do. Ruby stabby lambda syntax is added. Can use both lambda and stabby lambda. Stabby lambda, that's what they call it. It's a stabby lambda because it's got an arrow going to it in a direction getting stabbed. Is that what it is, stabby lambda, or is it just? That's funny. I don't know. Lambdas can be used as arguments to higher order functions. They can also be used to construct the result of a higher order function that needs to return a function. Lambda that takes no arguments, so area LB, xy, area rectangle area xy dot call. Okay, so this is actually a higher order function, area, and this returns a lambda, so it returns a function, so you call that function. And oh, that's interesting too. These parameters that you these basically become like binded, so it sort of binds the value of these parameters. So this function, so this is actually, these are actually parameters to a higher order function to generate another function, and then the value used in that function becomes part of that function. So when you call this area, you don't give it any parameters. It just calls the function that was returned by that was set up by this. So that's extremely interesting. Wow. Puts area, rectangle, area, triangle. Huh. Neat. Lambda takes one or more arguments, takes no arguments. Right, so this result, this takes no arguments. So this lambda takes no arguments, okay. Takes one or more arguments, so you can use, okay, so you can use this arrow and then have two parameters. Interesting. And then in the above example, we can see that lambdas can be called using both call and parentheses. Is there any difference between lambdas and procs? Yes, there's a difference between a proc and a lambda in Ruby. Let's find out. When would you use one and not the other? Difference is the way they handle arguments. Creating a proc using proc and proc new are equivalent. However, using lambda gives you a proc that checks the number of arguments passed to it. The RI. Okay. Ruby sometimes on Rails. Equivalent to proc.new, except the resulting proc objects check the number of parameters passed when called. Interesting. So lambda is a little bit different. Checks the arguments passed. So you get method error, undefined method, proc new, undefined, lambda, argument error, wrong number of arguments, 1 for 2, argument error, wrong number of arguments, 3 for 2. So, well, that's interesting. So the proc with AB, if you pass 1, it won't be defined because B will just be nil. And then if you pass more than 1 or more than 2, you just take those two parameters and the last one is ignored. Oh, that's interesting. So so for procs, the parameters you're missing just become nil and excess parameters are tossed out. Whereas with lambdas, if you're missing parameters or you have too many parameters, you have an error is thrown. Okay. Excuse me. Return inside a lambda returns the value of that lambda, but using return in a proc returns from the enclosing block. That's interesting. So lambda return foo, call foo, return local jump error, unexpected return. Proc new return foo, call local jump error, unexpected return. Oh, whoa. Oh, interesting. Okay, so a proc will actually return from the enclosing block, whereas a lambda is like a proper function. So for most quick uses, they're the same, but if you want automatic strict argument checking, it can also sometimes help with debugging, or if you need to use the return statement to return the value of the proc, use lambda. Neat. So returns and procs actually are. Oh. Okay. So you want to use lambdas in those cases. So you really want to use lambdas more than procs because you want to be able to return things typically. You are given a partially complete code. Your task is to fill in the blanks. There are 5 variables defined below. Square is a lambda that squares an integer. +1 is a lambda that increments an integer by 1. Int2 is a lambda that multiplies an integer by 2. Adder is a lambda that takes 2 integers and adds them. Values only is a lambda that takes a hash and returns an array of hash values. Okay. Fill in the blanks. Integer and squares it. Okay. Takes an integer and squares it. Increments it by 1. And multiplies it by 2. So I don't know if they have the bit shift operator, but that would be what you'd want to use to multiply by 2. 2 integers and adds them. Takes a hash and returns an array of hash values. Be like items or something, you know, or values. Wow, this is such a long thread. Look at this. Whoa. ABCD 0 return. It's good. We're looking for cones, Ruby cones. Learn to program. Learn Ruby the hard way. Nice. We're looking for this is not the documentation I'm looking for. I'm looking for the reference stuff, like the, where is it? Hold on, what's the main homepage? Looking for the, yeah, documentation, but I'm looking for the, what's it called? Library, not libraries, the FAQ, like the syntax, like the reference. Yeah, the reference, the, I don't know, where was I just looking at before? Like the syntax, there's, I don't even know what it's called. Don't even know what it's called. The, whatever you would call this, I guess the reference documentation, implementation documentation, something like that. I don't know. This is what we're looking for, though. Okay, whatever this search engine is. So we want to know. There's a particular call. Ah, yes, hash maps. Hash. That's what we're looking for. Okay, reference documents, I guess. Reference documentation. So we want to do something with the values. It's usually like keys and values or keys and items or something. Excuse me. Oh, that's interesting. Look at all these different things you can do to create a hash. Oh, supersets and subsets. That's interesting. Whoa, what did I just do? Just like something just moved. I don't know what that was. No, don't want to start that. That was a mistake. If the given key is found, returns a 2-element array containing that key and its value. Oh, okay, interesting. Clear. Removes all hash entries. We're looking for this is what we were looking for, but we're looking specifically for like values or oh, each pair. Given block with each key value pair return self. We want to, so it gives you an enumerator that you can operate on. That's good. We're not looking for each value. We're looking just for like excluding these keys. Oh wow, this is so interesting. All the things you could do with the hash map. All these different routines you might want to do. That's so interesting. Yeah, like I was saying, it's very, keys, there we go. And there's probably dot values or something. It's, as I was saying before about like, it's a very terse language because you have, 4 characters for everything that you might want to do with a, oh, I see, you can click on it, it expands it, okay, I understand. Things you might want to do with your different data structures and different objects. So yeah, really interesting. It's kind of, I think it's one of the reasons why Ruby is so popular is that it's just, you could do so much so quickly. Just a few strokes of a keyboard. So if you type, few keyboard presses. Slice turns a new containing the entries. Okay. Wow. Store is an alias. Associates the given value with the given key, returns value. Store. Hash bound equals. Oh, I see, for the operator for that. Oh, okay, I understand. It's an alias for this routine. Okay, I understand. 2A, new array. 2H returns self. Huh. Oh, okay, but you can also create a new hash. That's interesting. To proc, to hash, turns a proc that maps the key to its value. New string containing the hash entries. This is so cool. It's so interesting. I'm sorry. I'm kind of like just like looking at all the things that people thought to add to Ruby. It's super interesting. Added a lot. Values. That's exactly what I was going to try. Dot values. That literally was what I thought. It's exactly what I thought. And it worked. And I was right. Okay. I just wanted to confirm that. I was pretty sure that was right. First number, second number, eval, input hash. Oh, the eval too is pretty dangerous on a back end. I would say just never use eval. Just never do that, especially something in Ruby where things are so terse and it's so like there's so much, like, I don't know, you have so much access to things and it's so easy to do things, and objects are just totally like dynamic, and there really aren't like variable types and things. Like, it's just, I think it's also duck typed in Ruby, I want to say. So you have duck type variables and you've got, yeah, I wouldn't. Eval is so dangerous. Same thing in Python. A lot of scripting languages have that. I wouldn't suggest using that. It's a super dangerous routine to use. It's an extremely dangerous routine to use in your backend. Returns and assigns to $_. Not entirely sure what that means. What that is. The next line from the list of files in argv. Oh, I see. It's the arguments list. Okay. Or $**, or from standard input if no files are present on the command line. Returns nil at end of file. The optional argument specifies the record separator. The separator is included with the contents of each record. A separator of nil reads the entire contents, and a zero length separator reads the input one paragraph at a time. Or paragraphs are just divided by 2 consecutive new lines. If the first argument is an integer or optional second argument is given, the returning string would not be longer than the given value in bytes. If multiple file names are present in argv, gets no read it. So gets basically does some input processing, I guess. Just keep it simple. Probably could be more complicated than that. Like, you can read the detail of the docs to learn more about what exactly it does. Neat. All right. So fast programming that. Like, that was so fast. That was so quick. That's great. That's great. Closure is a function method that can be passed around like an object. It can be treated like a variable, which can be assigned to another variable, passed as an argument to a method. Remembers the value of variables no longer in scope. It remembers the values of all the variables that were in scope when the function was defined. It is then able to access those variables when it is called, even if they are in a different scope. Okay, so +1y, x equals 100, y.call remembers the value of x equals 1. Oh, x equals 1, y is a lambda x plus 1. Puts +1y. Number 2. In this example, the variable x, which is closed within the lambda y, remembers its values. Here, x remembers its value as 1. Oh, okay, that's interesting. Blocks, procs, and lambdas are closures in Ruby. Yeah, okay, so things become enclosed. Of no variables no longer in scope. Oh, okay. You were given a partially. No, that's not entirely true. I remember reading this years ago. I'm fairly certain I did, and I thought there's a contradiction in the logic here, because blocks can't be passed around like an object. Not exactly, at least. Not the same way that procs and lambdas can. Given a partially completed code, fill in the blanks. Block message printer prints the message if the block exists. Proc message printer prints the message inside a proc. Message lambda message printer prints the message inside a lambda. Okay. So lambda message printer prints the message inside a lambda. So we have a few different Ruby routines here. I also remember this being really frustrating way back when, learning programming languages and kind of wondering what the value of it is, and not realizing that like the technologies used to support software development are like, in some sense, not that complicated, but they're abstracted away. So you really do end up like wanting to learn programming languages more than anything else at some point, because a lot of the things that you'll program, like, they have sort of like abstracted away part components, pieces of it. So like an HTTP server, like I guess what I'm saying is like there were really basic pieces of technology I just didn't understand, that ultimately those things were just built using software in the first place, right? They are themselves just pieces of software. But not knowing what they do and how they interact and all that stuff, it was like, what's the value of learning these different languages if I don't even know how to like set up a basic website, right? Like how to do that. And there are all these different pieces involved. It's not particularly complicated, really. I mean, it depends on how you view it, but you can do things in such a way where it's not that complicated. And like, man, if someone just explained that to me when I was younger, like I'd be in such a different place. But anyway, whatever. Not really a big deal. It's just, you know, life's hard, I guess. Don't always know all the things you wish you did know. Something like that. Block message printer. Welcome to block message printer. Blocks given. Block given. Oh, that's interesting. So you can call the block. Turns true if yield would execute a block in the current context. The iterator is mildly deprecated. Oh, okay. If try, if block given, yield, else no block. Oh, the try, oh, okay. No, the try is the function name. I wouldn't name a function try in the docs. It's kind of awkward. Because try catch blocks are, also blocks are different in Ruby than a block in Java. Like a block in Java is just executable code and enclosed in curly braces. I think it's the same thing in C++ as well. All right, moving on. So what are we trying to do? Lambda message printer, my lambda message, welcome to lambda message printer, call my lambda, but in this function method. But in this function method, message is message. So we define these two things. So message equals gets. Block message printer puts this message remembers message. Yeah, so this is a block, and that we're gonna give. And so as block is given, we're gonna yield, right? We just print. Welcome, this message remembers message. But in this function, message is, okay, block message printer I think is called again. Later, must be. It says lambda proc and block. Okay. Interesting. So it should be the same message twice, the one that we get. And then proc message printer. This one is this message remembers message. And it should be, we're going to call my proc. We just call the proc. And then the lambda, we say my lambda, create a lambda function, which a message is bound. So it should be the same message in all of them, right? It's not like there's more than one message that we're binding, which is a little bit confusing. I don't really know what the point is. But a lambda is also a proc, so just say my lambda call or what have you. Random message, put in this function method messages, welcome to, oh. Wait, what? Oh, excuse me. Oh, I see. I didn't even see that. I thought this was a print message. Oh. Oh. So it'll be proc, block, and the other one is lambda. But the message is welcome to, but the message is welcome to, but the message is, and it changes to proc block and lambda, even though you'll have random message each time. Okay, interesting. That's just demonstrating closures, remembering their values as you call them in different contexts. I like that. It's good. I think that's different from, or that could be different from, I think that's good. I think that's different, or could be different from how it's typically done in either Java or C++. Although I think you can bind variables in C++ for your functions. Partial application, we create a lambda that takes a parameter and returns a lambda that does something with it. It probably does a similar thing actually. If you did like return x plus 1 in a C++ lambda, the closure, yeah, the enclosing value of x, it probably would actually give you the, I don't know, actually, I don't know if you could call, yeah, I think the closure would, actually, I don't know. I don't know how it works in C++. If you have a lambda expression, and we could try it. We could try it right now. Actually, this is kind of a neat thing. Have my handy dandy terminal ready here, and we can just say vim test closure, or just closure CPP. Oops. Testing. So now we can say closure. I don't know if you guys can hear those. I'm not sure if you guys can hear those noises. Let's see. Yeah, you can. That's gonna be annoying. That's fun. We're just gonna go ahead and turn that off. All right. We want to testing closures. Closure rather than closure. So auto f equals I have another function. Call function. Higher order, we'll call it. Higher order. And what do we say? We're going to start using camel case, right? So we'll start using camel case now instead of snake case. I like snake case. Higher order auto f. We're going to say return f. And yeah. So we'll call higher order of f. Really, auto is not in. Oh, interesting. It works. But auto is only available in concepts DS. Oh, interesting. Okay. I don't know what this should be, by the way. I guess this is just like a function. It's going to be like function that takes no arguments, void, and returns an int. I think that's all you need. Oops. Primary expression before int. How do you? Oh, I think it's this way, actually. I'm doing this wrong. Yeah, I actually think it's like this. F cannot be used as a function. How does this work? Auto seems to work okay, but this is a... Hold on. I don't remember now how to do this. I feel like I should. It's not a parameter pack, it's... Krunig lookup, argument dependent lookup, is the set of rules for looking up the unqualified function names and function call expressions, including implicit function calls to overloaded operators. These function names are looked up in the namespace of their arguments in addition to the scopes of the namespace considered by the usual unqualified name lookup. Argument dependent lookup makes it possible to use operators defined in a different namespace. Example. Okay. But I'm looking for function signature functions. Something like this, I don't know. Function template. Standard function, something like this. Function objects. Somewhere in there is what I'm looking for. A year of Python. Naturally, I would like to translate the laziness coming from Python to C++. The efficiency. Template rather than a function with the concrete type. There's that. Storing arbitrary function objects. Wraps callable object of any type with specified function call signature. Oh, these are so good. That's so useful. Where more? Oh, that's search implementation. Interesting. That's fun. I like that. It's interesting. I wonder, there was a live stream like years ago I think it was Boyer-Moore. I don't remember which one it was, but there was one of the search algorithms that when I was younger, I spent like days trying to implement one of these searching algorithms, and I wonder if someone noticed that was a long time ago. That was before I had a job, so that was like 6 years ago. So I'm wondering, 2015. So that was like 2015, 2016, around there. 2015, and then maybe someone saw that and they decided to add Boyer-Moore into. Oh, that's so much fun! Create string search algorithm for the function interface in C++. Wow, wow. Functions, lambda expressions, binding expressions, other function objects, as well as pointers to member functions and pointers to data. Yeah, that's what I'm looking. I want a pointer to a function, not a pointer to a member function, but a pointer to function is what I'm looking for. I want to show that in a. Yeah, how do you declare a function pointer? So nested name specifier, attributes declarator, pointer declarator. So I actually think it's something like. I actually think it's something like. It's a function f. It's a pointer, but it's a. I think you do this to just show that it's actually a function pointer. Excuse me. Higher order cannot be used as a function. I think there's some error here, right? Primary expression before int. I'm not really sure I understand. That's the return value. Pointers to objects. Address of operator. Array to pointer. Implicit conversion. Pointer to the first element of an array can be initialized with expression of array type. Okay. Drive to base. Implicit conversion. Initialized with the address of drive base. Polymorphic. Virtual calls. Operators. Algorithms to work with arrays. Comparison operators, strict total ordering, standard set map, pointers to void, pointers to functions. Okay, this is what we're looking at here. So a pointer to a function can be initialized with an address of a non-member function or a static member function because the function of pointer implicit conversion, the address of operator is optional. A pointer to function can be initialized with an address of a non-member function or a static member function. That's interesting. But this is the syntax for the pointer to functions. It's not the implicit conversions we're looking for. We're looking for pointer to function syntax. I don't actually know like where the reference to the function. Unlike functions or references to functions, pointers to functions are objects, and this can be stored in arrays, copied, assigned, etc. You can't store functions, and you can't store references to functions, but you can store pointers to functions. That's pretty neat. And they are objects. That's interesting too. Declarations involving pointers to functions can often be simplified with type aliases. Yeah, I imagine. I guess so. Yeah, it's array of functions, array of references. You can't have an array of functions, can't have an array of references, but you can have an array of pointers to functions. We use the left-hand operator of the function call operator, which is what we're trying to do. This invokes the pointer to function. Yeah, so we want a pointer to a function. Okay, so that's how that works. All right, I get it. We have I thought I wasn't sure what the syntax was. I tend to forget it, but it's a pointer to function f, and then it's void, effectively. That's more or less what our pointer to function. So the pointer to function syntax is you encapsulate your pointer in parentheses, right? And then you surround that. You have the function, the rest of the function signature. So basically, the function signature, it's the function signature, except the name has an asterisk in front, and it's surrounded by parentheses, and that's how you get a function signature. So presumably that gives us what we're after. Cannot convert main lambda to int. Oh, it's so annoying. Why not? Why not? All right. Can we? How about this? Can we set int pointer f to void to this function? I think it needs to be the address. Oh, I think we would need the address of the function. That's kind of interesting. So can we take the address of this? Address of R value. Cannot convert initialization. So it's interesting. I don't know. It's really weird. Can use standard function, which I think it's int. How does this work? It's standard function to convert the functional. That's what we want. Helps a lot. This library. Void int. Okay, you could do it that way. So you could do, yeah, int void f. Yeah, otherwise it gets a little confusing. Otherwise it gets a little confusing. But for some reason we can't automatically convert this lambda. That works. I don't know how you do this without, how you handle higher order functions without, while including lambdas. Higher order functions without, higher order functions without the functional. Yeah, that's really interesting. How does this work if I just use? So this is really interesting. If we use auto, if we use just use auto here for f, this works very nicely as well. Which is kind of weird. It's really weird. Yeah. A few things to say, like, clearly the closures work the way we expect them to. Oh no, it doesn't. Oh. Uh-oh. Uh-oh. No. Oh, that's interesting. Excuse me. That's what I wanted to see was, oh wow. Okay. Oh, that's very interesting. So no, closures do not work the same way in C++ as they do in other languages. Not true. Although it does work somewhat like this. This somewhat works correctly. If you bind y in each of these cases, in other words, if you do, it somewhat does work correctly in that if you do auto g equals f of y, right, and then you say g and g again, y equals 2, and then finally f cannot be used as a function. What? I think you need to bind. There are a few things here. So I think so closures don't work. Okay, so it took a while, but closures do not work the same way they don't work the same way in C++ as they work in Ruby and other languages. I think. Like, so this enclosing variable x actually is referring, this expression is referring to this x value. So if you change x, excuse me, when you call this function, it's going to give you when you, what was I saying? When you call this function, it's going to use this value of x from this scope as this value changes, so does what this return does. Now, what's interesting is, excuse me, if we, this G, we're saying f of y, some value y, and we're saying we're going to return x plus y. This isn't a function, by the way. This is actually an integer, this G. What you'd want is G would be calling f with y. Yeah, so actually y is a function that takes one parameter at this point. So at that point, like, then it's clear that this isn't really a closing variable anymore. So actually, really what G would be is f with if you bind y, right? So if you take standard bind and you take f and y, that's where things get interesting. You have to find where is, it says it's functional, part of functional. Okay, that's interesting. So this is kind of what you expect. So this y value now, even though we're changing what y is equal to, once we bind y, it's by reference. So it's by value rather, not by reference. So this G doesn't change, even though we change x, and this x is enclosed x changes, even though this is the enclosing scope. Using this G, passing this to other functions, and using this in other context, it still actually refers to the what x is referring to, which is very interesting. So as we change x to 100 and to 1000, G updates. However, we change y, it doesn't matter because we already bound y to this function. And similarly, if we bind x to f, as opposed to pass it as a parameter and bind it instead of using it as part of the enclosure, then part of the closure, then that's also would give us the behavior we probably would want. So no, C++ works differently than other Ruby and other languages in terms of closures. Not necessarily. It's kind of how you would expect it to work, still, but it's not. Doesn't work the same way, which is very interesting. So, yeah. So let's see. Does this still work? Gen random characters. Oh, nice. We can remove that if that doesn't work properly. Oh, I think. Oh, that's interesting. So. Wait, what? Wait a minute. Why? Oh. Okay. Huh. What? Core dumps? Why is it core dump? What is going on? Construct null not valid. What is going on? What's the issue? Oh, yeah, you need the... Okay, that's why. I think it's .size or .length. argc I think tells you how many arguments there are. I'm going to call this gen random characters. Oh no. Oh, okay. Really should be 2, I think. Oh, interesting. Okay. Wow, that's fun. That's fun. Whoa. Oh, software's great, man. Oh, you gotta enjoy that. You gotta enjoy that. Yeah, that's a good time. Okay, anyway. I was just wondering why my program was so yeah, pointers to functions, kind of complicated, I guess. Not complicated, but what was I saying? Pointers to functions. I forgot what I was even saying. Pointers to functions. In C++ are kind of interesting. You'd want to use the functional library, however, without using the functional library, how you'd pass functions around is, yeah, kind of unusual, kind of, yeah, would be kind of involved, I think. You can use pointers to functions, but you probably would want like a wrapper, just so that way passing those objects around is not so complicated. Those classes around, passing the objects around. Which I think is what the functional library more or less gives you. Although auto is what I was using. I don't even know, like, it's interesting. Passing lambda expressions using auto is like very peculiar. But anyway, works, but it's very strange. It's a very strange thing to do, in my opinion. I don't even know what like the hand-coded translation necessarily would be, because it's sort of like an anonymous class. It's, I guess at compile time you know what the name of the class is, something like that. So you actually couldn't do it by hand, sort of. I don't know. I don't know. It's okay. Partial application, we create a lambda that takes a parameter and returns a lambda that does something with it. Partial function application. Partial function application is the ability to take a function with many parameters and apply arguments to some of the parameters to create a new function that needs only the applicable application of the remaining arguments to produce the equivalent of applying all arguments to the original function. Yeah, so that's basically binding. That's effectively binding values. So v1, v2, param1, param2, partial f, param v1 returns f prime, param2. And param v1, param v2 equals f prime of param equals v2 for any v2. Also, I think that this is related to currying too, which is a similar thing. Well, currying is like you kind of apply one at a time, but partial application parameter. Other parameters are not explicitly mentioned. This is a recurring feature of partial function application. FS. Okay, we don't really need to go too deep in this. Oh yeah, C++ would be interesting to see. Probably uses binding. Oh, no binding. Oh, I guess this is from a long time ago because it didn't use binding. It uses templates instead and argument forwarding. That's interesting. Reference forwarding rather. R value reference forwarding. Huh. So, copy, array, transform. What are they doing? So they're saying p apply, fs declare type, f1, f1. Fs is just a, excuse me, returns an array, takes a function, and takes an array I don't know what this is. But this is a function that we're passing. And f1 is the x's and y's. fs f1, x's, fs f2, y's. There's f1, f2. f1 is just return x times 2. f2 is square, so f1 is double, f2 is square. P apply with transform, most stream iterator out, so you print, right? Copy from A to B. Oh, excuse me, this is a, no, not transform. This is a, it's just an overload they're using with an array. C. And this transforms F, applies, it looks like beginning, ending, beginning. It looks like this is applying right F to the array. It's just returning. You're just returning the same array. It doesn't create a new array or anything like that. Wasn't aware you could do that, but that's kind of neat. Sort of under the impression that when you transform, you have to place into a new array. It's not the same array, but I guess it works in this instance. So applying F to the array, that's fs. Okay, so p apply with fs f1. Say p apply. We have p apply. Oh, it's recursive. Oh, whoa. What is going on here? So f and arg are template parameters, and we're returning p apply f and arg, which this is a function, but this is an object. Excuse me, templated object. So you have some f, which again is a templated class, arg, templated, both of them are value references. So we're going to return this object p apply with f and arg, and this really is a constructor. So we're constructing this templated object, and we're forwarding these two references. So I mean, it's really just calling it a constructor. So I don't really know. It's not really necessary to do that, I think. but okay, fair enough. Instead of calling yeah, this is sort of a wrapper around the constructor, I guess, just to make it nicer. So struct p_apply. Here's the constructor. You have a function f, you have an arg, you have two classes, right? It's templated. Return type, obviously forwarding the references for these two classes using r-value references to construct. Oh, I see. So simple enough, r-value references to, and forwarding those references to construct the also f underscore. Is that supposed to be like that? That's interesting to me. I don't know if you need to do it that way with these underscores. Oh, excuse me. Oh, that's how they're templating it here. Oh, I see. Oh, I see the point. Okay, I get it. I get it now. Right. So this is templated with different parameters than this, is the point. Which is really weird. That's why it's underscore. Okay. I've not seen that. I mean, I've seen things like that before, but I don't see why they're doing it here. That's maybe a better way of expressing it. Interesting. So, well, I guess these could be like subclasses or something, not necessarily. That might be why. Not necessarily exactly this class. And then, oh, my neck. Oh. Return type of f only gets deduced based on the number of arguments supplied. p_apply otherwise has no idea whether f takes 1 or 10 arguments. Oh, that's interesting. So the function operator uses a variadic template to pack the arguments and unpack the arguments. So you have the operator. We don't know what it returns. And we say over these we're going to forward reference all these r-value references. Now this is a little bit weird. And this auto. Oh, I see. Okay, you can basically give it a hint for the return value. I think that's the issue, or part of the issue. You don't technically need this, I think, if auto works nicely, but it may not be able to without this hint. So in the declared type of f of args, standard declare value of args. Okay, I don't really know what's going on here. Come back to that in a second. That's something I probably should know, but don't know that offhand. Return f of arg forward. So what we're doing is basically unpacking, doing some unpacking here. Really interesting how this is put together. So you call with no, excuse me, this is call with parameters. Only gets deduced based on the number of arguments supplied. p_apply otherwise has no idea whether f takes 1 or 10 arguments. Okay. So you have this constructor, you take a function, you take an argument, and when you call, you're actually going to call the function that you've been given to this p_apply, and it's going to use this argument that you've bound. It basically binds an argument, and then you're also going to call on this function all of the other arguments that might be required. So basically, your function call to p_apply, I guess when you apply it once, binds the first argument, and then the rest of the arguments are just passed right through to f, as you normally would. I think that's the idea. So this kind of creates like a facade that you've bound an argument. This is basically like before you had the bind function in the functional C++ standard library, you would use something like this to and this kind of basically supports binding and supports, you can call it currying also. Both of these, both binding is effectively binding a variable to a function. It's kind of what it's doing, but it's if you had to write it from scratch, this would be like one way of doing it, I guess, is sort of the explanation. Yeah, and you're just unpacking all the other arguments here. So you apply the forwarding reference to these R value references, and then this is just the syntax for that. So it's just sort of an encapsulating function call, and then the unpack syntax just follows that function, that those changes to those variables. So this will apply to every variable in the pack. So it's just a variadic. So basically, yeah, so it's just another way of saying, so this part we need to understand though next, or I need to understand that next. But the basic idea is you're just calling this operator with a parameter pack of R value references, and then the first argument is bound already to this object, and you do want to the return value depends on f, so that's why you have a declare type of f, and actually just whatever the return of this would be depending on the arguments. And again, it's going to be instead of the forward reference value, you have this argument, f of this argument, with the now it's interesting, the declared value of this pack, it's almost like you're unpacking here as well to get the different types of each argument. That's kind of interesting. Yeah, it's interesting how the declare type syntax works. It's basically you call a function. You can either use the class itself, like you could use declare value of arg, or you can use or just arg itself, and then similarly you would use declare value of these, call that function on this parameter pack. It's interesting how you do that though. I guess it's here you take the argument for args, and also I think what's interesting is this forwarding reference. The template argument you use is actually args, the parameter pack, and you also have, and you include the argument itself to unpack it. That's kind of peculiar. That makes sense, but it's definitely kind of peculiar. Yeah, you kind of have, because you have a template parameter pack and a regular parameter pack. Yes, that's why this is interesting to me. Okay, because I don't really have like too much experience tinkering with templates and parameter packs in tandem, but this makes a lot of sense. So you're unpacking both of these are actually two parameter packs. One of them is a template parameter pack, and the other one is just a parameter pack. And you're unpacking both of them in tandem. That's why you write it this way. Similarly, you don't actually need the args declared values. You just need the template parameter pack to unpack that. That's why this looks this way. Okay, that's very interesting. And the declare value basically just takes some class, and then that's all you need. You don't need any inputs to the function, so you just call that function with the class type, and there you go. So okay, I think I get it. And this allows you to do things recursively too, because you can now take the result of p_apply and curry it again if you wanted to, because you're going to take some function f. Now, what's interesting is, I think all you need is support of this operator, this function call operator, and you can use that as a class for p_apply. So you can actually use repeated instances of p_apply on the same function to quote unquote, yeah, as we said, curry the. Is actually another way you can call this is currying. Another way you can understand this is currying, to curry the function. Neat. alternatively binding variables to the function call. So we p-apply, so fx declare type of f1 is, now where is fs? fs, so fs is actually a higher order function. No, excuse me, it's not a higher order function. fs is a function, transformation function. And so we're going to p-apply to this function, this parameter f1, which if we see this function takes one parameter. Okay, that makes sense. So we're binding f1 to fs. Oh, that's also really interesting because no, actually fs is a higher order function. No, what is, that's so confusing. Yeah, fs takes another function as a parameter, but it doesn't return a function. So what we're doing is we're binding the function to fs, f1, and p-apply in this case would then, I guess in that case it would become, only in this instance it would become a higher order function, but it is returning another function. So I guess it is a higher order function then. But it doesn't always take another function to return a function, so that's confusing. So it's not necessarily a higher order function, but in this case it happens to be one, just the way it's being used. I think this is like really confusing piece of code because we're like combining functions in this way. It didn't have to be a function that we're adding, that we're binding. It could have been something else that for a first parameter. But yeah, but the first parameter that we're binding is actually a function, f, and so that's why you gotta get the declared type of f, and yeah, because f of s, right? Because f of s is templated for that function, so we would want the declared type of that function in order to bind. Okay, so you need that. Yeah, that's interesting. So that way you could properly template f of s for that function. Yeah, got it. Interesting. And then you do that for, so f1 and f2, fs f1, fs f2. Basically we bind the first function and bind the second function, and then we call them. The first function we said doubles, the second function squares, and then we do the same thing. We call it on the first array and call it on the second array. And what's also interesting is they don't use standard new line anywhere here, so you see all these new line characters. So we have x's, fs f1, fs f2 tabbed, and then y's tabbed, fs f1, fs f2, and then these are the results. Excuse me. That's a really interesting piece of code. Yeah. So partial. So yeah, this is again currying, binding. This is a lot better. Excuse me, a lot more succinct. I think. I guess you could say a lot more succinct now with the functional functional library added to the STL in C++. But this is how you do it before you had the functional. Before you had the functional library in the STL, you could do it this way. By the way, you could also, well, what's interesting about this is that you kind of have to be somewhat selective about the arguments you pick, in that you can't bind, like if you had two variables A and B, you can only bind using this approach. You can only bind A and then bind B subsequently. You couldn't bind B first and then bind A later. So, and I don't know if that's necessarily true also for the functional interface now. I don't know if they've changed that, if they've if things are different, because as I said, like it's I guess it's sort of a non-trivial thing to be able to bind one particular parameter. Now you can, if you were to use hash maps and named parameters, then I think you can do that in a way that's relatively straightforward. However, it's not obvious how to do that at all. How you might do that in C++, especially because you don't have really named parameters in C++. So that's a curious thing. I don't actually know. Fortunately, I don't think you need to query things that often or that much, really, realistically. But if you wanted to, you had to. You have some support built into C++. So yeah, that's kind of curious. I could try that actually. I could test that right now if you could bind. Let's take a look at that. Test binds. IO Steam, IO Stream. Oh. Let's include, right? I bet you we get an error if we do this, retry this. So we're going to say auto G is equal to F. Say standard bind. F with, yeah, so I think actually even just the way it's constructed, I think even just the way it's presented to you, yeah, you can't actually select the arguments. It's variadic. So forwarding call wrapper for F, calling this wrapper is equivalent to invoking F with some of its arguments bound to args. List of arguments to bind with the unbound arguments replaced by the placeholders. Oh, interesting. Oh no, you can actually selectively bind. Okay, neat. Let's actually see some examples. 1 and 2 are from placeholders represent future arguments that will be passed to F1. So 2, 1. 1 is bound by 1. 2 is bound by 2. 101 is unused. Makes a call to F2, 4, 2, 1, and so. Oh, there you go. So placeholders is how they do it. Oh, that's really interesting. Okay, there you go. Standard placeholders. So you can do. That's super interesting. So you can bind in C++ using. Oh, that's really cool. I like that a lot. So you can, if you wanted to, you can bind 1, 2, and 5. And now you can say. See out testing bindings. G of 5, 10. And actually you would do standard placeholders. Whoa. Whoa. Okay. I don't think so. Oh, it works. Whoa. I was not expecting this to... Not at all expecting that to work. No kidding. So, yeah, so that's really interesting. So these placeholders actually provide a mapping between when you call the function where those arguments are. Oh, that's so interesting. That's so cool. I wonder how they implemented that. That's like really neat. But yeah, that allows you to mix and match your bindings however you want, which is a lot more involved, or a little bit more involved than the currying that we just saw for partial application. Yeah, I like the bind functions for C++. I think that's great. I like that a lot. It's from 4 years ago too that they put this together. Yeah, how old is this? Placeholders. I wouldn't have thought to do it that way. Let's go to bind. Yeah. So this is 2011. So this is from way back when. This is from interesting. Goodbye, hello, hello, goodbye. Yeah, so that's 10 years ago they came up with this. I mean, it makes sense. You know, again, currying is kind of a well-known thing, and so you might want to bind, might want to be able to bind things in C++, but it's clever. I mean, it's a clever thing to do. So anyway, yeah. So how are we doing on time? Been at it for 3 hours now. Okay, not bad. So partial application, create a lambda that takes a parameter and returns a lambda that does something with it. Excuse me. All right. Multiply function, number do, another number do, number times another number. Doubler, multiply function 2, tripler, multiply function 3, doubler, tripler, and the above. Example of lambda will take a number as a parameter and return a lambda. When you call this lambda with another number, it will return the product of the two. You are given a partially complete code. Your task is to fill in all the blanks. Here, combination is a variable that stores a partial application, which computes combination and choose R. Oh, okay. Neat. All right. So, interesting. So we get NR, and we say combination N. So a combination is basically you're multiplying by one less each time. So we're saying combination is going to be a lambda. So we do something like this. So it's a lambda that returns another lambda. Okay, interesting. Call it X. And we're gonna, instead of a do, we'll have a block. Instead of a block, yeah, we'll just define the block a little bit differently. And then we're going to return another lambda. Y. Okay. So here we have multiply function is we take this number and we return a lambda that has this number. and then that's the lambda that we have after we call this, and then we can call that with a number. So what we want to do is, I mean, we really just want to bind n to our function. So really just n into r. And this is going to be from, it's really 1 to r of the product, or we're going to use reduce. And we're going to have another block, and it's going to be, so 1 to r is going to be a and b, and we're going to take, I start off with 1, I think, instead of 0, and we're going to multiply. It's going to be, there's a is the running a times b minus a, n minus b. Yeah, something like this. Let's see if that works. Hey, neat. Let's do 10, choose 5. That's kind of a big number. I don't know if it's right. Go for it. 4, choose 2. So you get 4, and you get 1, 2. So you have 1 times 4 minus 1 times 4 minus 2. I don't think that's correct, actually. No, that's not right. No, it's got to go from 0 actually to r. And that's too many now. It's r minus 1. I think it's got to go this way. Because you're going to do n times, oh, actually, these aren't combinations, these are permutations, by the way. Oh. Uh-oh. Uh-oh. You can do, you can say denom, the denominator is going to be 1 to r reduce 1 of multiplication, and numerator is going to be this. Does this not have a yeah, denominator? Okay, I think you take the permutations and then you divide it by r factorial. I think that's the truth. Yes, that's right. This is actually the permutations. And this, I mean, this is fine. This is just AB, A times B. I also think it's better to use denominator, to use the whole word. even though you could say D and num. This is much more like Ruby kind of syntax. This is much more Ruby style, like just a couple characters. Yeah, r factorial, and you're gonna say this is n factorial over n minus r factorial. Is that right? Yeah. All right, let's go for it. There we go. Hey. Not exactly. Probably not the best way to do that, by the way. Probably not the best way to do this. It's one way of doing it. I think Ruby uses big integers also, so Python does the same thing. All the integers are just max sized. So not the most efficient thing, but it works, I guess. Whatever works. Yeah, that's exactly what I was going for, right? So n minus 0, n minus 1 to n minus r plus 1, which is 0 to r minus 1. You can actually do it this way. I think this is better. You can do plus 1. I think I would prefer that approach. Because it's simpler to understand what's happening there. Alrighty. Yeah, it's basically just a list of numbers from 1 to r. Alright, let's go to the next one. So I think I understood with that problem. Which a function accepts n parameters and turns it into a sequence of n functions, each of them taking 1 parameter. Oh, excuse me. I thought that was what currying was. I thought currying was what we just did, was the partial application, but apparently currying is a little bit different. Multiply numbers x, y, do x times y. Doubler, multiply numbers curry dot 2. Multiply numbers dot curry dot 3. Doubler 4, tripler 4. Oh no, currying, yeah, it's exactly what we just described. I think that is what we did, right? I think it's the right, I don't know, maybe I'm struggling here to follow. Above example, lambda takes 2 parameters, x and y, returns the product of the two. Multiply numbers dot curry dot 2 returns lambda, which takes only 1 parameter necessary for calculation. Partial code, your task to fill in the blanks. Write a curry which pre-fills power function with variable base. Power function with variable base. Okay. So power function x raised to the z, base, so we're going to curry it with base. So equals power function dot curry. So we're no longer camel case though, I have to remember that. Base. It's interesting that you dot call. That's weird to me. Kind of wasn't expecting this. Like, so this is you're going to call the curry function here, and then that actually is a function itself, which you then call. Okay. And that'll give you, and you call it with this parameter, and that gets you this raised to power function. Interesting. Neat. So that's what currying does. It's actually is a function. It creates a function itself, which you have to then call to get the function you're looking for, which makes sense, but kind of not exactly what I was expecting. It's kind of expecting the curry function call itself would give you, like, you would call curry with an argument, not call curry and then call the resulting function with an argument, which is a little bit weird. Slightly different, not the same thing. It's not the same thing. You can, yeah, if you're calling curry on a function with, like, that's kind of actually how the binding seems to work in C++. So you actually call binding, and you have a function argument, and you have different parameters that you can sort of mix and match, and you can use placeholders and whatnot. Currying, on the other hand, though, actually in Ruby, it creates a function that you then call that function with a parameter, and that'll give you the other. That'll actually give you the other functions that you're looking for, the ones that have bound variables. So that's kind of interesting. Lazy evaluation is an evaluation strategy that delays the assessment of an expression until its value is needed. Ruby 2.0 introduced a lazy enumeration feature, and lazy evaluation increases performance by avoiding needless calculations. It has the ability to create potentially infinite data structures. Whoa. Oh, I've seen this before. I've actually used this in the past. Not used it, but I think I've tried to solve this problem, and I was so confused, stuck on it. Power array. Yeah, I remember this. This is really interesting. I think Ruby's the only place I've tried it or used it. I think in Python it exists too, but yeah, this is very peculiar. So power array size do 1 dot up to infinity dot lazy dot map x raises power dot first array size. Puts power array 2 to 4, 1, 4, 9, 16. 2 to 10. Oh, I see. So it only gets, so lazy evaluation, it's basically you get part of an infinite data structure potentially. Oh, wow. Yeah, I think I really struggled to understand what this was, like way back when. Lazy evaluation, okay. Interesting. Really interesting. Lazy avoids needless calculations to compute power array. If we remove lazy from the above code, then our code would try to compute all x ranging from 1 to float infinity. To avoid timeouts and memory allocation exemptions, we use lazy. Nice. Now our code will only compute up to first of array size. Yeah, you can use first to get the first few elements of a lazy sequence. That's really interesting. Okay. Task is to print an array of the first n palindromic prime numbers. For example, if the first 10 palindromic prime numbers are 2, 3, 5, 7, 11, 101, 131, etc., input format a single line of input containing the integer n. You are not given how big n is. Print an array of the first n palindromic primes. Sample put 5, sample put 2, 3, 5, 7, 11. Okay. Wow. That's really interesting. I don't actually know. We need to use a primality check though. So we might need how can we perform relatively efficient primality checks? Well, palindromic numbers are not really too hard. So I guess the question is, we can write is palindromic, and then we can use a sequence of prime numbers, and then we can use a sequence of, we can filter those prime numbers with palindromic a palindromic filter. So we could say something like, all right, so we could say something like the prime numbers, just the regular prime numbers, which would be primes. So we're gonna make primes a lazy list of prime numbers. So say power array. I guess we'll say array size. We'll say get primes. Power array size, we'll just say n. And we'll say, oh, the other way around. So get primes, we have up to infinity, right? Lazy map. So what we want to do is generate the next prime number in the sequence. So we can say we have a get prime check that we're going to use, or is prime check, which we can just check against all the other primes we have so far. So we do that recursively then, I guess. So we'll have a base case. I wonder if this works. I don't know if we could do this, but we could try. So if, not if, yeah, well there's if, right? If, and end if, or just end. If n is less than or equal to like 1 or 0, then we return empty, an empty list of primes, right? Otherwise, we say cursively use the previous prime values. So we're going to say previous primes are going to be get primes of n minus 1, right? And I like the way they do it, where they don't have parentheses. Get primes, we're going to say we don't know. Next possible is going to be previous primes dot last. I don't know if they have that. Getting the last in the list. -1, okay. Same thing in, that's the same thing in Python, they do the same thing. So actually we should do two base cases, because I want to guarantee that there's a also want to return. We want to guarantee a few things. We want to guarantee that this function call won't cause an error. So there's always at least one element in the array that we're looking at. Less than or equal to 1 is empty, but if it's 2, then return 2. And we're going to say next possible is previous primes -1, and we'll say check equals false while not check, or yeah, while not check, or search while, or found. Say found equals false while not found. Do it that way. Found. We're going to say you can do any of, right, Ruby has any. Any element meets the criteria. Args. I don't think that's what we're looking for. It's not any. It's basically, well, all is really what you want. Actually, all. It's true of all elements of self meet a given criteria. Call the block on each returns true if the block returns only truthy values. False otherwise. So if all of them don't divide, so on everything from previous primes, if previous primes, all of them don't divide next possible. So next possible modulo, call it A. Right? So if for all of these do not divide A, for all of the previous primes, if they don't divide the next possible, then that'll return true. We're going to say found equals, right? And then while not found, so actually we do that first. Oops. So found is going to be the previous primes dot all check if this is a previous primes plus 1, right? And while we're not found, we're going to update. Found, we're going to say next possible plus plus or plus equals 1. I don't know if they have a plus plus in Ruby. Nope. Operators. Arithmetic, maybe? What about just the basics? Pages, class of module index. There's so much. There is so much. Yeah, mutexes. OpenSSL. That's pretty good. Psych. I don't know what that is. Rack. Oh yeah, rack is interesting. I think rack has something to do with usually I think it's RACK, not RACC. I'm not sure what RACC is. Rinda, Ruby, signal symbol. I don't know. I just want to know if plus equals and or plus plus is supported. But yeah, so we're actually gonna do a very brute force kind of approach to get the primes. So previous primes, get primes at -1, next possible previous primes. Found is previous primes all, right? And we're going to say, yeah, so we're going to use this to find our sequence of primes, and we're going to say up to n. I don't know how to do this. I don't know. I don't actually like lazy evaluation. It seems kind of not that great, really. Or at least the way that this is expressed, because like you're never going to need an infinite number of things, so everything is lazily evaluated anyway. Like I don't really get it. This is actually kind of a challenging problem, regardless of whether or not it's lazy evaluated. Yeah, I don't know. It's a little bit weird. How does lazy figure out how many you need? That's another question. I guess you need to use it in conjunction with something. You can put lazy wherever you want in between, I guess. Yeah, in this case, it's kind of simple. We're really just generating a sequence, and then instead of generating it only over one element, we're generating it over, like, we're kind of just specifying the bound in the sequence here. I guess it's a little bit easier to specify things because you can do like we can do a map of like is prime and is palindromic, and then just take the first of those, and that's maybe a little bit easier. Yeah, let's do it that way. I said it's a lot easier if you do it that way. Okay, input is a single line. All right, we'll do it that way. It's fine. Sure. Is prime of x. We're actually gonna make this like really, I guess, blunt. Really simple, really blunt. First we'll do is palindromic, and then we'll check if it's prime. Because there really aren't that many palindromic numbers, so that might be easier. So is palindromic, we're gonna say x equals reversed x. We could say 2s x2s dot reversed. That might be the right way to do it. And then is prime, we're going to say 2 to x minus 1 all, and it's going to be, let's call it a, we're going to say x modulo a equals, is not equal to 0. So it's none of the other numbers divide this number. Really it just has to be the other prime numbers, but we could just use the other numbers too, that's fine. And this could be up to really the square root of x. We could do x dot square root dot floor, or roof, maybe ceiling, that's probably better. Yeah, so all those don't divide, none of these divide, and then you say 1 up to float infinity. Why wouldn't this be integer infinity? Yeah, why not integer infinity? Excuse me. X raised to this power. X, we're going to say filter, really, so not a map, filter. X is palindromic of x and is prime of x. Something like this. What do you mean useless? We just call this check of x is palindromic prime of x, and then filter x on check of x. What's wrong? Okay, yeah, that makes sense. What's the issue? Also, I think is prime might be part of actually something in Ruby already. No, these should be question marks too, by the way. Forgot about that. Unexpected token. Why? I'm a little confused. What? I guess we don't. Okay. I don't know. What's wrong? I am so confused. Useless assignment. Useless assignment. What do you mean? Oh, you know what? Lambdas use a dot call, right? It's not. Oh, I see. That might be why. That might be why. Ah, that's the issue. I see. There we go. Okay, that's the problem. Okay, it's just me being a little bit confused as to how lambda expressions work. Uninitialized constant, infinity. Oh, okay. I guess this is all we got then, float to infinity. So take back what I said before about the currying. I think I was wrong. I think in order to call, I was wrong before about what I was saying with the curry function. In order to, excuse me. No, right. Curry, it'll give you, that will actually give you the function which you then call. The way to call that lambda expression, there's a dot parentheses syntax in order to actually call the thing that got returned. So I was wrong about that. But no, well, yeah, I actually guess it's kind of interesting because the curry, again, no, the curry itself, I would think the curry function would have like, you would call the curry function with the parameters that you're binding, but that's actually not what you do. So that's interesting. No implicit conversion of string into integer. Oh. 4 characters to do that. Do you mean reverse? Reversed. Oh. Okay. Of course. Of course. Alright. Two levels. Square root. Oh. Okay. Big math. Big decimal. Integer. Square root of x. Do we need to import the module? Maybe? Math.square root x. And there's a ceiling. That ceiling. Yeah, okay. Wrong answer. Oh. Okay. One 3 5 7 11. 2 3 5 7 11. Oh. I mean, oh. Palindromic. Start with 2 instead of 1. Hmm. Oh, I see. In that case, I gotta start with 3 then. Well. Oh, I see. Ah. Okay. And just say end, you know, x is greater than 2. I don't know. Oh. Huh. Get a pass on 2. 2, 3, 5, 7, 11. Wrong answer. So just make this a list? I don't know. What's wrong about this? I'm so confused. Why are these printing on a new line though? Can you make a list? Undefined method. So that's kind of interesting. I don't know what the problem is. What? What? I'm really confused. Very confused. 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. I don't get it. What is wrong? What are they expecting? How are we doing on time? I need to eat food. I think we should take a break soon. We're approaching 4 hours. What is the issue? Excuse me? My head hurts. Excuse me. I really think I need to take a break soon. Filter. Wait. What? Oh man, having a hard time reading this here. Whew, excuse me. Array filter is an alias for array select. Calls the block if given with each element of self, removes the self. those elements for which the block returns false or nil return self if any elements were removed. Turns nil if no elements were removed. Turns a new enumerator if no block given. Excuse me. I'm so confused. Don't get it. Oh. What? Oh. They don't want us to return anything. They want us to just print it. Oh. That's why I was so confused. Okay. I thought they wanted us to return the array. Okay. Well, this might not work because this might be inefficient. Oh, no, it's fine. Okay. Let's get to see. Alright. That should have been a lot faster. But yeah, I didn't realize they weren't. Okay, I should check the output I'm looking for. That's super simple, right? Super simple. Okay. Also deleted is interesting. A few people are deleted. So I guess these are people who either were employees at Hackerrank a long time ago, or were people who used Hackerrank a long time ago and they ended up not using it anymore. Stopped using it at some point. I think I need to get to 5 stars before it'll tell me how many problems are left to solve. Besides simple methods to iterate over objects, Ruby Enumerable provides a number of important higher order constructs that we shall explore in further challenges. One of such important methods is collect method, also known as map. Map, as the name may suggest, takes a function and applies it to a collection of values one by one and returns a collection of results. Oh yeah, map is great. That's what we just used a filter, which is similar to map. That is map of f of x with all these items gives you f of x sub 1, f of x sub 2, etc. Single powerful method helps us to operate on a large number of values at once. For example, 1, 2, 3, map x, 2 times x, 2, 4, 6. A1, B, B2, C3, collect key value, 2 times value, 2, 4, 6. Note that these methods are different from each in the respect that these methods return a new collection, while former returns the original collection irrespective of whatever happens inside the block. In this challenge, your task is to write a method of which returns an array of strings containing secret enemy message bits. In this challenge, your task is to write a method which takes an array of strings containing secret enemy message bits and decodes its elements using RT3 ROT13 cipher system, returning an array containing the final messages. For example, this is how ROT13 algorithm works. Original text: why did the chicken cross the road to get to the other side? Applying the cipher. So it's a cipher. Okay, rotate by 13 places. Sometimes hyphenated ROT13 is a simple letter substitution cipher that replaces the letter with the 13th letter after it in the alphabet. A special case of the Caesar cipher, which was developed in ancient Rome. Because there are 26 letters in the basic Latin alphabet, ROT13 is its own inverse. That is, to undo ROT13, the same algorithm is applied, so the same action can be used for encoding and decoding. The algorithm provides virtually no cryptographic security, is often cited as a canonical example of weak encryption. It is used in online forums as a means of hiding spoilers, punchlines, puzzle solutions, and offensive materials from the casual glance. ROT13 has inspired a variety of letter and word games online, and this is frequently mentioned in newsgroup conversations. Yeah, okay, so ROT13 ciphers. Like super simple cipher, which I didn't even know what ciphers were when I was a kid, so ROT13 would have been really interesting to me. But relatively easy to decipher. Yeah, so rot13 message. You take each character and you rotate it by 13. So what you would do is, oh, I see. That's why you want to map. So you can map secret messages .map, and what we're going to perform on our map, we use with our map is each character, right? What do they want us to do? They want us to array of strings. Okay, secret messages .map message m, and m we're actually going to m.map, and that's going to be the rot13. So we're going to take, that's character C, and we're going to say C plus 13 modulo 26. So convert the character to, oh no, don't know if it's uppercase or lowercase. Uh-oh. 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 Well, okay. So we could just say use an if statement. So if, we could do something like this, I guess, then. So we'll say C, say if is upper, C dot is upper, something like that. Then do the following. Else if lowercase, we'll do another block of things. I think this actually should go up to the top. And we're gonna say, yeah, so upper, that's what we're looking for, or it really is upper, home, upper, uppercase. How do we, character, let's try character related. There's another way to do this, and using ASCII text, but there's a way. There's got to be a way to do it in Ruby. Really, there's nothing more idiomatic. Also, jobs. All those jobs. Oh wow, dude, that's a lot of jobs. Oh boy, I get like I'm eligible for like a ton of jobs. I guess all I really got to do is build a Ruby on Rails app, and then I'm on my way. How are we doing on time too? Almost 4 hours now. Yeah, look at all these jobs. 100K plus remote, Nashville. 120K plus remote. 120K plus again, remote. There are a lot. There are a lot. Ruby or Elixir. That's like what everybody's doing. Yep. Ruby on Rails, Ruby on Rails. Yeah, there are a ton of Rails jobs. So upper match, regex pattern. That's the most. Yeah, okay. I mean, there's like there are a few different ways to do it. That's one way. The other way would be there's a bit for characters that specifies whether it's a uppercase or lowercase, and you just check if that bit is flipped on or off. So you would say the bit is actually 32. So the difference in ASCII between uppercase and lowercase is 32. So 64 I think is A, character A, and then 96 is capital A. Or excuse me, 64 is capital A and 96 is lowercase a. So you would say C and 32. If that's true, you could say is, you know, greater than or equal to 1, or really is equal to 32. That's uppercase, and then the other one is lowercase. So, no, excuse me, that's lowercase. Yeah, so this would be lowercase. This is another way of doing this. So then you would say you'd return C minus A plus 13 modulo 26 plus A, which these are really 64 is what that is. And you do the same thing over here, but for uppercase. This is as opposed to using a regex match. You can do something like this. See what this does. Oh, then, okay. Is that how it works? It's if then in Ruby. Just say if control if expression. Oh, it is if then. Okay. Then is optional. Okay. But do you execute a block, or do you just execute multiple? Do you need the? Oh, that's what's missing. The else. Oh, it's just else. Okay, never mind. No, I was gonna say I thought. That's my fault. That should be fine. Okay. Is that the issue? Do we need these? Oops. Maybe that's why. Maybe I should have. Dat map. Really? There's no map for strings? It's kind of weird. Really? Well, you can do characters.map, I think. That might be what we're after. And then we would say toString maybe, something like this. I don't know. That's so confusing. Let's break this up into pieces. Let's do this. We're gonna print m.characters.map, or not even map, just m.characters, and also turn m.characters. Just m. Let's see what happens when we do this. Void value expression. I am so confused. What? Did you do that? No, this is like nothing. This doesn't even exist now. This is just a comment. Oh boy. Totally irrelevant, this part. Don't see what the problem is. Alright, anyway. What is going on, man? It's just a comment. Leave me alone. Compiler. Leave me alone. Getting tormented by my compiler here. Alright, whatever. Just get rid of it. It's fine. It's freaking... What's going on here? Method must return an array object. Okay, so... The character. So can we map each character to... like just, I don't know, C, and then return just uppercase A. Yeah. Okay. Must contain only strings. And then can we collect those? Take that at the end of that, and then just like toString. Like what happens when we do this? No. Oh, join. That's what I want. Yeah. There we go. Okay. So now if we say what we had before, which is basically if C and 32 is equal to 32, then we're going to go do some things, which would be C minus, so this is lowercase, right? C plus 13, so we're going to rotate 26, right? And otherwise, we use capital A. All right. Yeah, join. That's what it was. That. Now I remember that from all those years ago. Use a split and join. All right. Where is the syntax error here? This I think might have to be like so. I think for Java that's the case. Expecting unexpected brace, expecting then, or no, why is that the case? So this is strange. I mean, this is just a block. And yeah, this syntax is fine, but for some reason this if else is not okay. That I don't really understand. I mean, you can just say A, right? And, oops. An A, right? Like, why is this particular syntax wrong? Maybe we need this. Why? What about just if true? How about that? Why are we running into problems here? I don't. What? Oh, it's because we're missing an end. That's why. That must be it. I keep forgetting to add those. This end. What if we put it then? All right, we put it then. What is the issue? What is the problem? Unexpected new line. Is that it? It's just unexpected new line characters? I guess blocks aren't supposed to have new line characters. Is that the issue? Because that would be really annoying. That would be really annoying. I don't know, whatever. We'll just use a lambda function, I guess. Rotate character. C. It's gonna do this. Like, I don't know what's going on here. It's having such an issue, but it's not that important. Or it shouldn't be that important. Not supposed to be that important. Yeah, basically what we were supposed to have is we call this block and then, oh, we don't, is that too? We have the characters, we map those characters, we have each message, we get the array of characters, we map that array of characters to a set of new characters, and then we join all those characters to get each string. That's it, really. It's just each message becomes a rotated version. I'm so annoyed. Why is this such a problem? Why is this such a problem? If true, then do these things. Why is this such an issue? I'm just annoyed at this point. Why is this happening? What is going on, man? I don't know. Just do that. How about that? How about that, please? Hopefully, maybe. I don't know what is going on here. Oh, please, not again. It's gonna be such a hard time about this. Okay, so that compiles, but why? Okay, can I do an if statement? So if true, return A. Is this syntax wrong? Is that what's going on here? I know we need an end. Is that what it is? Is that we don't have, is that not Ruby syntax? Print hello world. Something like this. Maybe that's the problem. Oh, that is the problem. Okay. So you're not supposed to have brackets. You're not supposed to have a do block. That's the issue. That's just okay. That's annoying. I'm annoyed. Definitely annoyed now. So that was just not the issue at all. Okay, I think I get it. I think I get it. Not even remotely. This actually was just. Switching between languages is rough. It's definitely rough. Okay, at least it compiles now. So block and route 13 undefined method. I don't know what that means. So this is not, so for some reason this isn't correct. So we just return A though, that should be fine. Trying to figure out what's wrong. Okay. So this is fine, but this if statement, so what if we did return? Does that help? I don't think so. Maybe this expression is incorrect. How about this? How about oops. Return A and return A. Oh man. This is kind of rough. This has been kind of rough so far. All right. So I don't know what's going on here. For reasons that are beyond me, this just doesn't seem to be working. Like the if statement. I can't get the if statement to work. Why? What is go? Oh! This is the method that's undefined. Oh, the ampersand, the and. Okay, I get it. I was so confused, but I get it now. All right. Now I understand. Because these aren't really characters, so we have to convert this to a character. Oh, I see. I think I understand. Got it. How about that? Okay. I was so confused. For so long, so confused. Oh man. Okay. How about to see? Oh, it's not a character. We want just a character. Oh, all right. Characters. Array of characters, shorthand for string to each character 2A. A block is given, which is a deprecated form. This works the same as each character. Oh, okay, interesting. 2A does what? A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. Two A is just not here. Where is 2A? What does 2A do? What is that? Oh, to an array. Okay. Huh. Where's for each though? Or for each? What's the other? Where is this? Is characters? What does this do? Each character. Okay. That's really what we want to do. All right, that's really what we want. We want each character, not really map as much. Rotate the character and then join these characters, and really. Oh, it actually kind of joins everything at the end anyway. I think, yeah. So I don't think we necessarily need to join anything, and then we can say. So the question is, are these characters that are being used? These integers? Yeah, I mean, that kind of does what we were expecting it to do. It does sort of the same thing, joins at the end, but the question now is, I guess it's to I. I don't know. I don't really know what character processing looks like in Ruby. I think you probably would. Yeah, something like this. How? Sun's in my eyes. I don't know. Yeah, character processing in Ruby seems to be kind of different than other languages, or just slightly different, because it looks like when you try to operate, when you iterate over the characters, you're iterating over not those Ruby characters. It seems like you're iterating over strings, right? Like each of these are strings in the excuse me, passes the integer ordinal of each character in string, also known as a code point, when applied to Unicode strings to the given block. For encodings other than values are directly derived from the binary representation of each character. This is kind of more of what we want. Kind of want each code point. So they're in Python you have like an ordinal and you have a like string, so you can convert back to a string from an ordinal. So so let's see if there's like a Ruby ordinal or something like that. I think it was one of the things I got stuck on like years ago when I was integer ordinal, one character string. Yeah, okay, that's what I want, ord. So C for each character, we're going to say x is c.ord, and then now we can say x and return x minus a plus 13 rotated plus a, and this is actually going to be string converted back to a character. Not exactly what we're looking for. Chop. We actually want to go ordinal to character in Ruby and Buri. Yeah, so Python, so ord we can get, that's fine. If you want to go backwards. Yeah, I think this is something I got stuck on when I was playing years ago with other folks. Like basically the game was, what was it called? I forgot the name, but it was you're trying to program the question faster than anybody else. And I think one of the things I kept getting stuck on was trying to use Ruby to convert between, like to do character manipulation, string manipulation. And I think one of the issues was exactly what you're seeing here, is that converting from a single character to its ordinal back to performing some manipulation and back to its character. I think I kept getting stuck on this in Ruby, so I would switch to Python or I'd switch to some other language to do that, because it seems to be kind of a nuisance in Ruby. Ord, how do I go back? Oh, dot sum is what I should have used before, by the way, instead of the reduce. Dot sum was better. Does not give the correct result. How do I go back the other way though? Convert. Excuse me. ASCII integer to character Ruby. It's got to be a conversion function already ready. Ruby treated characters somewhat inconsistently. Question mark A would return integer represented character's ASCII value. These characters would only be represented by a one character string. Mysteriously turned into integers if you want to get character ASCII value. Ord. No, but I want to do the other way. I want to go from like an integer to an ASCII value, not the other way, not this way, but the other direction. I mean, I realize there's a map you could use, but like to character, not of character. Come on. I think this is what I want. Yeah, this is it. Really simple. CHR on each byte value. What? Oh man. Didn't we just look this up? I'm losing my mind. Didn't we not just do this? You gotta be kidding me. Really? I don't know how that works. Is there integer CHR? Is that what it is? So confused. Oh, no, wait, I'll go back. Oh, this is the right, okay. With an encoding, okay. Turns a string containing the character represented by the int values according to encoding. Alright, never mind. Whatever. Okay, fine. Fair enough. Now, I guess, so you would need the ORD of these two. Oh boy. So annoyed. Feel really dumb. I don't know. I don't even know anymore. I'll just say things got really confusing suddenly. So this is the correct way to do it. Yeah, so I guess Ruby actually is the other way around. It's actually Ruby's fine to do this. I guess. I don't even know what I'm talking about anymore. Who knows? So, okay, great. So we have our character C. It's a string with one character. We take X, we get the ordinal for X. We say if X is, so let's say it's like A, 64. Yeah, lowercase. Lowercase would be 96, I think. So this bit is flipped on. So I think we need to check this first also. That might be part of why it's not correct. And then let's actually go ahead and print this. Method must return an array object. QRYGN. Also, there's that too. QRYGN. Method must return an array object. What? Oh. All right. Each character, we're gonna return. Let's do characters. Map. Rotate each character. Join. How about that? What does that do? I'm so annoyed. What? Yeah, I think what you're seeing is the result of being unfamiliar with Ruby, like not having gone through like a lot of these kinds of exercises where you tinker and finagle and you see what the different return types are. And I think it's also one of the temptations in Ruby is to like kind of pack everything into like one or two lines, and it just gets really confusing. This is really annoying though. Yeah, so let's just print M. Start with that. What does M look like? Returned object must contain only strings. Okay. If we actually return M in our block, then okay, we would fail. All right. We print each one. Okay, great. So now let's process each string. Let's print X, return X, and let's let X be M. Right? Should do the same thing. It does. Okay. Let X be M dot map, or not map, dot each character, and we're going to say each character C. It's going to just be A. See what that does. Okay, it doesn't do anything. It does not do what we were after. That doesn't make a lot of sense. How? What? Okay. String. Okay. All right. Sure. Sure. What? Now, why? What string do we get from this? That's the thing I'm so confused about. What is going on here? Like, what do we just return C? See, that's the thing I'm really confused about, is that this should return a string. I think this just returns itself. The previous, like, this doesn't actually modify the string at all. I think that's the problem. That's part of the issue here. I don't know what that's doing, but okay. So if we map, though, if we like m.map, what does this do? You don't have a map for string. That's kind of why we were doing characters.map.join. How about that? What do we get when we do this? All right. And if we say rotate character.c. What does this give us? Delta meet at chocolate corner. Delta meet a Delta meet at a chocolate a corner C name in to a backup at a it's midnight extraction. Oh. Oh, I didn't even think about that. The issue seems to be because there's spaces. That's the that's the problem. It's the spaces. You gotta be kidding me. If C is equal to a space, just return C right then and there. It's a subtle thing. No, not this again. Not this again. Syntactic errors. There we go. Delta, meet at chocolate corner, 10 men, 2 backup teams, midnight extraction. Oh, I did it. I got it. Oh boy. Wow, that was torture. That was brutal. Oh man. Wow. So I think we just broke it. Oh man. Oh. How are we doing on time? 4:40. Okay. Wow. Yeah, that was rough, man. All right, let's try running code again. Just don't print these things. Okay. Oh boy. I thought this was gonna be so much easier. Boy, was I mistaken. Boy, was I mistaken. Oh, that's great. That's a lot of fun. Yeah, I definitely need to take a break, get some food, take some time. So yeah, we want to skip the space characters, and right, we need to get the ordinality, ordinality of the characters, and that's basically the ASCII integer. And then you also need to convert them back to characters from integers. And this will return a string of one character of that particular character. So that's how you do that in Ruby. And you can use, again, 32 will tell you whether or not you're dealing with 32 will tell you whether or not it's a lowercase, uppercase character. 32 is actually set for the lowercase characters. So that's another way of doing it. So you could also use a regex match, as someone else just explained, but you don't really need to do that. Yeah, so I'm just thinking what to do here. You actually can do a little bit better than this. You call this like alpha. And then you can say you can actually just add, can even do, you don't even have to have an if statement here. There you go. Don't even need an if statement. That's fun. How about that? How about that one? There you go. Excuse me. Yeah, you'd want to do this for each. So you can get rid of the space by performing, you do m.split.map, and then you do each character. We'll call this word. And then you don't need this anymore. Each word you would say characters.map C join so messages you'd split into strings, each string, or yeah, you'd split into word, each message you'd split into a word, each word you'd split into the characters, and then perform the rotation and join, and then each of these words you would then join with a space. And that also works. Wow. There we go. Not bad. And then ideally we would actually change the, so you can update this part to, you put it on one line, I guess. I'm wondering if this still works. Yeah, that's fine, the white space, not a big deal. So then we could do words, and then each character, and then inside here, we can say, basically, and then just put this right in there. Probably better to put that on the same line, or yeah, actually maybe not. I don't know. I'm not sure where that should go. Maybe put that on another line. Get x equals c ord alpha. I think these need to have separators, and then this is what you return, and then obviously that kind of goes here. Join, join, join. Don't really know the best way to do this. And that works. Technically one line. I don't know. I don't know what to make of this or to think of this exactly. In my opinion, probably not the best way to do this. Just seems kind of strange, I guess. You can also just do CORD in both of these spots. And then you can even go so far as to put the alpha, just plug that right in. Put this all in one line instead of using X. Yeah, you could do that too. You could do that too. That's fine. I don't know if that's a good idea, but it should work. That's pretty interesting. This is what the this is what the solution looks like on one line of code. It's pretty funny. This is your rot 13 here's your rot 13 cipher in one line of Ruby code. Wow, imagine that. Okay. That is ugly. I wouldn't do it that way. I think the best way to do it is to actually use the function that we had and like use a lambda expression. You know, if we're gonna map. I don't like this kind of chain mapping this way where it's like nested mappings. I don't think that's good. It just looks kind of weird, you know. Like maybe you can do it like this, where you know, each function kind of gets its own spot, and then you can do a line here, and that's joined, and you could do a line here, and then that's joined, and you could do a line there. Like this might be a reasonable way, but even this is still kind of ugly because each of these kind of get their own. You know, you're sort of tabbing everything in, and then here I guess you would say, yeah, x.cord, and then, but then it's kind of on its own line. You know, that's the thing is like it's kind of ugly. You know, that doesn't really look right either. And then putting this on its own line seems kind of weird. And then you have, you know, we said, yeah, we'll just call it t is equal to this expression. And then ultimately this is what you return, right? T plus this, mod 26, plus T. So you have x minus T plus 13 mod 26, and then add T. This is probably better. I think this is like the correct way to do it, quote unquote. Not the correct, but probably better than what I had before. Like this is much cleaner. The function's just right in there. You don't need to use a lambda expression or anything. You can avoid using the if statements that we were looking at before. You can actually add the if statement in here too if you wanted to. So you can do m instead of split and join again. You could do m characters map and then just skip the white space, and you save yourself one join. So here, I think this is better to do it this way. Part of the issue though is now you have this if statement, which is if C equals this, then we just return C, which looks a little bit strange. But this works too. Maybe this is the best. Oh no, it's not working. No! Oh, you need the end if. Oh, interesting. We map each message. You map the characters to this map, and you join all of these characters, and you return this message, and they're saying this is not an array. Well, that's not true. What? So that's confusing. What's going on? You have your messages, you map them. For each message, you're going to take the characters array, and you're going to map each of those messages. You're going to check for each character, you're going to perform the following, and then after you've converted all those characters, you're going to join them together to a single string, which is, I think, correct. That should return an array. You're joining these characters. You could say x equals this, and then print x, and then return x at the end, just to see what's happening. Delta, method must return an array object. Isn't this exactly what we were doing before? What went wrong? What if you return that if statement, remove that if statement? What happens? Okay. That's why. Because blocks don't have return statements. That's why. Okay, it's a good thing we practiced this. Yeah, that's a very subtle, that is a extremely subtle detail. You can't use this return statement here. Blocks don't have return statements. It's annoying. Lambdas do, but blocks do not. Nope. Nope. Can't do it. So you have to have an else. Yep. That's very interesting. So there's no return statement though. It's just the last. Yeah. So it's just C. That's kind of weird. I don't know if this really works then. Doing it this way. I think you do need to use a lambda then, if or a proc of some kind. That's very interesting. Yeah, there you go. So you can use the if statement, or you can switch. You can remove the if statement by using remove the if statement by using the split before the split and the join again. But this could be any white space. C matches any white space. use a regex match for that. I think that would be not a bad idea. And actually, I like that. Let's try that. Let's do regex match C, and we're gonna say white space. How about that? No. Alright, I need to take a break and go get some food. Actually, I have the documentation right here, so this should be not too hard. Oh, this is regex. Yeah, so we want, excuse me, now I don't know what this does. This is a kind of match check also. Oh, here we go, the basic pattern matching. I think the match will still be quote unquote truthy. So you don't necessarily need to match, but you can do, it's probably better to use this tilde equals tilde, form the regex match on C. But still white space is what we're looking for. A white space character. So backslash S, backslash S. Let's see. Hey, I like that. I like that. That's a little bit better than using the split join routine, because the problem with splitting on white space and then joining again is that we don't know what white space we split off of when we join again. So it's easier to just skip the white space using something like this. I like this better. All right, I gotta go. I'm getting kind of tired, sleepy, frustrated, all those other things. Ready to get some food, hungry, grouchy, all that. How many more do we have left? Unsolved. Quite a few, actually, but not that many. We can probably count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27, really not that many. We do 3 more and we'll get the, so how many stars do we need? We need 5 stars to get to see how many are left. How many did we do today? I don't think we did that many today. We really should practice JavaScript though, I think. I think tomorrow we'll do JavaScript instead of Ruby. I think what I'm going to do is get some food, come back, we'll do Ruby for like an hour, and then we'll switch to tomorrow we'll do JavaScript instead of Ruby. So I really do need practice. Yeah, because that's kind of what employers are looking for. It's Ruby and JavaScript experience. Yeah, I think I mean I have that experience. It's just I don't know. I don't do it like so often and so frequently and so much that I'm programming these languages that I'm like extremely what's the word, like extremely quick about writing code. You know, I kind of like I run into snags like you just saw where I have to like look up syntax and kind of finagle things, and like just plain old language proficiency really is a thing. But I mean, as you can see, like I'm familiar enough with programming in general that I can still kind of meander my way through, but at least like coming up with a solution, I'll definitely be able to come up with a solution relatively quickly. But how to actually convert it to code through the particular language of choice definitely is a relatively involved task. Takes time, experience. You kind of eventually memorize each piece, but all of the languages kind of have the same basic constructs, basic things. So it's not that difficult. But something like Ruby, it is like it's very different than the other languages. Like each of these languages are very different from each other. Python, Ruby, C++, JavaScript, Java. I'd say those five. If you're like pretty good with those five, then you really have a lot of options. Which that's kind of the goal here. Yeah, I mean, I've been struggling with the like on-site interviews, I guess we'll call them. Not on-site. Yeah, I guess so. We'll call them on-site. Like, I really should be programming in like Python, I think, for these different interviews where they want you to actually program something, actually code something, and actually have some code written. Reason being, Python's basically it's often used for like in pretty much all the firms out there use Python for something, and it's a relatively easy language to just code something up quickly, which is what you're asked to do in an interview in 1 hour. Start programming something. So I think Python's probably the way to go. But it's definitely I don't know. It's challenging. It's hard. It's definitely kind of hard. Yeah, I don't know. I think I'll just improve slowly over time. Just keep interviewing, keep practicing, keep going. I'll just get better and better as I go. I'm pretty good when it comes to the like the interview question, like the algorithm, data structures, and algorithms questions. I've spent a lot of time on that, so I'm quite proficient with respect to those. I think I'm actually reaching a point now where probably just about any question they ask, I should be able to handle it. Like even the like LeetCode hards probably could do. I don't want to say that because like those could be really hard. Like those could literally take me days sometimes. But I've definitely been able to do like a lot of the LeetCode mediums kind of on the spot relatively quickly. I mean, they're still pretty hard. I shouldn't say that. Like I'm not like totally prepared, but I'm reasonably prepared, I think, for most firms that aren't, really quizzing super hard on those things. Anyway, all right, I'm gonna go. I'm like, I just feel like I need lots and lots of practice, and it's tough, man, because I have, I don't know, I'm making it sound like, okay, here's the problem. I'm interviewing with a lot of firms, and I have just a lot of interviews lined up, and I'm kind of like, I just want to spend more time studying because I just feel like I'm just not quite good enough. But the other thing too is like I've been programming for so long, like I've got to be good enough. I've been programming since I was 14, programming since I was a kid. It's like I've got to be good enough. Like there's no way that I'm not good enough for these things. So anyway, I'm gonna go. Thank you for watching. Talk to you soon. I think I'm gonna go to the bathroom, go buy some food, eat, relax for a bit, and then probably come back, maybe do like an hour or two, and then go to sleep. And then tomorrow we'll try to get more time in. We'll see how we do tomorrow. But yeah, there's just a lot of work to do. It's a little bit crazy. But yeah, I'm gonna go. All right, take care. Bye.